Did he miss?
Yeah.
Okay. Let me grab the link,
Okay. If they go to
cut it into
Chicago,
chat.
Send it to me.
Huh?
If they go to
I'll send it to you. I'll send it to you first.
But if they go to a penalty,
Who put in my phone? Thank
I
you.
did.
Brazil versus Croatia.
I don't know anything about
It's
soccer.
tied 3 minutes with penalty shootout. Interesting.
Okay. Paste it into the main chat if that works. If not, we'll connect your headphones for audio.
Oh.
If it works is the
What
thing.
is that?
I think
What? Free kick.
I can't test it.
Oh, shit.
But it's not a penalty.
Someone else.
I know. Yeah?
Thank you.
Because my device is connected to the whole projector. Let's hope I don't look horrendous on camera.
You look amazing, Jesse.
Oh.
Say something.
Hello.
Okay.
Something.
Welcome.
Jesse, it's more important than
Oh, okay.
There will be a delay, so clap and then you will hear it and start counting my call.
Yeah, you are loud and clear.
Okay, it's only 20 seconds. That's really
So
all right.
I'll be moderating, I guess, or like I'll be keeping an eye on the live chat.
Sure.
I
can actually see it from here.
If there's any questions, who's watching from home? Other
Just
than
Uh,
Amanda?
for sure,
A number of
Amanda.
people.
I don't know, maybe other people who.
YouTube, right? So
Yeah.
we'll save afterwards.
Yeah.
Okay.
That's the beauty of it.
Zoom in on the screen record on YouTube.
Chat. Chat. Any questions? Chat.
Oh yeah, it's a bit hard to see.
Yeah.
Oh, because I think it's
Final
just because
whistle.
everything else. Okay, I can
Extra
make this
time.
all dark.
Wait a minute. I don't think I can zoom in, but I'm just gonna like pull it up to the front.
Just make it all
What are you guys watching?
Brazil versus
like
Croatia.
this.
Oh my god,
Is it better?
they're in penalties?
They're gonna go into penalties now. Extra time just ended.
Shit. That's crazy.
Are you supporting anyone?
No, I don't give a shit.
Understand.
I like watching, I just like seeing people score.
No problem,
I'm like,
Valentina.
"Dang."
I like watching the highlight reels.
Yeah.
I'm
I
that
don't
kind of person.
I could care less about who wins, but
So Valentina and Amanda are
See,
watching.
I want Croatia to
home.
win because Brazil won 5 times already. Like, give someone else a chance.
yeah, I agree.
Yeah, really sorry about the janky ass setup, but best we can do.
All right. So I know this is a bit off topic, but I just think it would be appropriate to talk about electromagnetic waves here, just because it is a second order differential equation. Originally, he did talk a little bit about like separation of variables, which actually uses the exact equation, and I just think that it would be useful to learn for electromagnetor. So the first thing that you do with any electromagnetic kind of problem or computation is that you pull up the Maxwell's equations. So in this case, I've chosen to do it in terms of B and E, just to keep consistency. So first, we can investigate how electromagnetic waves look like in a charge-free space. So what a charge-free space means is that there is no charge, so this goes to 0. And also there's no conductive current, so this would also go to 0. In which case, and also there is no one second. Shit, what's happening over from the other side? I think my laptop's glitching out. Yeah. Also, my bad. This is supposed to be 1 over. Sorry for that. So we can rewrite this in terms of, this should be E. Oh my god. So we write this in terms of E is equal to this.
Sorry.
Oh, good.
Really
So-
sorry.
What are you trying to do?
He's
We're
trying to
trying
make this
to-
light off and this
Yeah.
one's
Oh.
on, so that
But
the
there's
light.
only, there
Just
are
two
two
light
light
switches.
switches.
I think everything off is better. I mean, is anyone ready? Yeah. Thanks.
There you go.
Sorry. It's okay. Yeah. Can you see your paper?
Oh, yeah, I'm fine.
Okay. Then just leave all the lights
I
on.
have a white
Okay,
light on my computer.
Oh,
Alright.
So something funky happens if we just attempt to take the curl of curl. So I know this looks super wonky, but there's kind of a reason for it, and that's because we have a vector identity which looks like this, which can relate a curl into something that actually makes sense. Where this is the Laplacian operator, and this means to take the second derivative in 2D. So like imagine if you only had one dimension, then you would just replace it with your regular operator. In fact, you can just replace it with your you can just assume that you only have one variable. So that's what it would look like in 1D. So we can try to plug things into this, right? If we try to plug if we try to take the curl of the electric field, then on the right-hand side we'll get the curl of like negative b over t derivative. We can take the negative outside of the Laplacian. We can also take the derivative outside, so we can get the derivative t. And notice how this matches up with what's up here. So we can replace what's inside of the brackets with what's up top. So we can get this is equal to so now two derivatives is just taking the derivative twice. So we can write this as the second derivative. So the electric field is somehow related to the second derivative of the magnetic field. And if you do the same with the other equation, then you can also take the curl of like the magnetic field. You actually find the exact same thing. You will find that it has identical relationship to the electric field. So just one moment. And substitute this. And then we can substitute in the original equation it was negative t. So we get the same thing. Oh, sorry, my bad. Why did I miswrote this? I'm sorry. This should be E. That's why it might have been confusing people. So we find out that the curl of the magnetic field and the electric field actually relate to each other in an almost identical way. How do we explain this almost identical relationship? We go back and unravel the right-hand side part of the equation. So I'll just mark this as left-hand side. This one is right-hand side. So what does it mean to take the gradient of the divergence, right? So the divergence is specified to be up top, to be 0 in both cases. The divergence of electric field in a charge-free space is 0. Same with the divergence of a magnetic field. It's also 0 in this case. So if you take the gradient of like just 0 everywhere, it's just 0 everywhere. So this term just cancels out. And we're left with the negative of the the negative of your thing. So if we equate both sides, we'll start to find that bring the left hand side together, we'll get the t together is equal to the negative. And if we want to put this on one side, right, we'll get, actually I can write the one in terms of, and in this case, whatever V is, right, it's just whatever you've put. So E can be, this is just an arbitrary like formula that you need to replace, right? So V can be replaced with E or B, whatever scenario is appropriate. So in this case, we've replaced your V with E over here. So we should also replace V with E over here. So we replace that. And as we said that if we only consider 1D case, this is just the second derivative. Let me just make sure this is not wrong. Oh, sorry. This would be the second derivative with respect to the position. So just to be very clear, so both of these waves are propagating in time, right? Both of these waves are inducing each other, and the sine wave feature emerges with time, right? So the oscillation beams like through space, versus in this term the Laplacian is with respect to space. So for space we have to use vector calculus. So this would actually be x squared up down here, and if we were to rearrange this, we'll find that just bring it all to one side. Oh my god. We've just replaced the Laplacian, so there's no need to write it again. I'm making so many mistakes.
Also, Jesse.
Okay.
I don't know enough to call you out on them.
So we realized that when we go and physically measure the speed of propagation, the speed indicated by taking a derivative with respect to t, we find that it's just the speed of light. So it turns out that this constant evaluates to speed of light squared over 1. So the electromagnetic wave can just be expressed in terms of a term that changes with respect to time and one that changes with respect to space. And actually the same identical thing goes for magnetic waves. So if we were to just go ahead and replace this with B, it will also be true. And that's why we know that the electromagnetic waves, right, they are kind of, let's say, related to each other in a very close manner. So this is just one application of a second order derivative. Of a second order differential equation that is relevant to us. So disregarding all of this random stuff, we can move into actual stuff that's calculus. So I guess we can go into Fourier transforms if we want. So just one show of hands. Do anyone want me to actually go over the derivation of Fourier transforms?
Can you also explain what they are?
Yeah, sure. So essentially what Fourier transforms is, it's a very useful algorithm in signal processing, where you can like decompose a specific sound into or like a specific feature into a lot of things in terms of significance. So if you were to like represent let's say that I take one line out of an image in JPEG. Let's say a block is like 8 things, right? Like they might have like levels like that. And then I want to represent this step thing in terms of a bunch of additions of waves. So just to be clear, like this is the axis of like volume, and this is the axis of time. So let's say I want to represent this wave. Go for it.
So you're saying this is like imagining this as a JPEG line.
Yeah, imagining this is
Brightness?
8 pixels in terms of their brightness,
Okay.
right? So then if you were to regularly store this image, you might want to store like a certain number for each one, right? You might store like 2, maybe like 1, 2, 4, something like that. And you have to store 8 of them. But if you were to store this in terms of Fourier transform, you can store like the most significant feature. The most significant might be a sine wave like this that has 2 wavelengths across. And let's say that another significant one might be the one that has 3 wavelengths across. And so if you can store the most important ones, you can just disregard the ones that look like this, right? Because this is not actually going to cause that much difference to your final image if you were to just lose this information. So Fourier transform gives you a way to decompose any sort of random pattern into a lot of representations of sine and cosine waves. But obviously, in this case, it's discrete because it has like multiple data points. In our case, we're dealing with functions which are continuous. So it's a very useful transform. Like every single thing uses it. Your phones, laptops, shit like that. And what we're gonna learn is a formula to represent any sort of function in terms of sines and cosine waves. So this sounds a bit weird. Let's see. Should I just present the formula, or should I go into derivations? Like, which one do you think?
Formula and then derivation.
Okay, sounds good. So the way that you want to represent, so usually in transforms we don't want to confuse the original function with the final function, with the transformed one. So usually we will say that small letter f is like the original, and then big letter f is the transformed. Don't be confused with the Laplace transform, which is transforming your function into another space. So Fourier transform is just a different representation, but Laplace transform is transforming it into a space with respect to S. So if you ever see the S, like this is Laplace, and this is Fourier, this is original. So to convert between your to convert into your transform, you will use the formula which looks like this. Your big F is equal to
Shouldn't the input of the transformed function be like frequency? Not x.
frequency. Oh, actually, in some cases, yeah, you can write this in terms of frequency, like. But frequency and x is just like linked with like frequency is usually represented by omega, the angular momentum, and then x is just related to that by like pi relations. So I don't think it matters that much which one you write. So you want to go from positive infinity to negative infinity so that you deal with the whole of the function, and then you want to use your e to the negative e to the ikx with your original function and dk. So k is just a random term that I've introduced that you should integrate. And then I think to reverse it, just to make sure I'm not teaching you wrong things. Give me a moment just to check. Um, okay, so, oh, interesting. Interesting. Okay, my bad. So actually, I did already teach some wrong things. Glad that I checked. We don't care about this guy. Because our okay, I'll show this later, but this is just some sort of artifact of taking the thing. Okay, my bad. I should memorize this. I should legitimately memorize this for the life of me. Yeah, don't come to my stream, man. I'm bad. I'm gonna teach you wrong things. It's gonna be number 2.
Hey, it's fine. You're gonna get on the higher end of the bell curve.
We'll
To
see.
plan out along.
We'll see. You know, maybe.
Wait. Sorry, one sec. Okay.
Yeah, no, we changed the entire thing because we felt like changing the entire thing.
Wait,
So,
so why is this on low? Oh wait,
Yeah,
so this
yeah,
is
so you
the.
should change
yeah, my bad. This is the other. This is how to convert it back.
Oh,
This is my bad. Yeah,
What?
no, I just confused the two.
What's K?
Just random variable I've introduced that you should integrate.
Okay.
Yeah.
Cool.
Because we just needed a new variable, so too bad. K is the victim. Mhm.
Sounds like we're introducing a lot of. I'm not gonna finish that thought.
Yeah, no, you should not.
We're
W.
introducing a lot of complications.
K.
Let's just only use integers.
I will go check.
Yeah, if you have his notes, right, then the one that he presents is one that might look slightly different. I think he also presented like something like the 2D formula. I'm like, oh, that's useless. Like we're
Oh,
not
yeah,
going
he
to
did.
use that. So, just trying to make this slightly okay. All right. I see the problem is like I have this iPad which has all of the other notes that I have, so I can't flip through them. So change was on the screen. So too bad.
He has the square root.
What?
Does he have the square root in
He
yours?
does have this. I think I remember.
He does
being
have
a
the square root? Okay.
Here, this is what I have.
Wait, can I see? Sorry for that. No, it's fine.
This is what I have. I don't know if it's correct because I don't understand anything, but I wrote down what he wrote on the book.
Oh, okay. He's doing the way where both guys take a. Oh, okay. This is a much easier way to remember, I think.
Let's do it that way then.
Yeah, because this just looks identical now. Only thing is one guy has a negative on the IK and one guy doesn't. So
Oh, it's pi.
yeah, so I'm just gonna write this. Oh, just making sure that with respect to frequency. Yeah, that works.
A prop.
I'm just gonna write this in the same kind of way so that it looks good. All right. After confusion, we got our formula. Oh, I guess then
Isn't that just identical but with different?
yeah. So you just transform it back in the same way that you kind of did. So the reason why he has the like 2 pi over here, it actually doesn't quite matter what magnitude you end up with as long as you are consistent with your inverse versus your forward. So by distributing it halfway into like each, it's just slightly easier to compute, I suppose. Or like slightly easier to remember. We can do an example just to confirm that what we have is correct, right? Because if we're trying to decompose our thing into a lot of sine waves and cosine waves, then if we just put a sine wave function into it, it should just give us like discrete values, right? So we can just try like fx is equal to sine of omega t, just for sanity checking. Oh, okay, let me not use omega because this is confusing. I'll use a. So if we want to transform it, we'll get 2 pi of 1 of this guy and that guy. We get the e to the I k w. We get the sine of at dk.
I have a quick question.
Yeah.
Oh wait, no, I don't have a question.
My bad.
I just read stuff.
Oh, okay. That's good. Honestly, I find Fourier transform a little bit confusing, like as well. 'Cause it's like, why does it work? You know?
T. F of t, not f of x.
There's a good
Oh, my
there's a good
Oh.
3 Blue 1 Brown video on it.
Oh yeah.
The idea is that like you have the e negative ix term, right?
Mm-hmm.
That like
Rotates you
that's-
on a polar
that's a
coordinate.
rotation.
Yeah.
And you have your original
Mhm.
function,
Yeah.
and if you multiply that, you're gonna get like some sort
Mhm.
of
Some sort of circle.
pattern.
Yeah.
And if you like change
Mhm.
like the k term is
Yeah.
how much like the speed of the rotation,
Mhm.
and if you change that and it
Yeah.
happens that the center of mass, that's the integral, like when it hits a significant period, the center of mass is going to be it's gonna like be higher than
Okay.
the ones for the other frequencies.
That's interesting. That's a interesting explanation, because the one that I saw was like, if you were to have a hydrogen atom, you have an orbital, right? And you want to like find out where your electron can be, then like your electron must also conform to some sort of Fourier transform, and then you must have a period. You must have something which conforms to the 2 pi period, which is why you end up with the 2 pi on this term, and then everything else is just using coordinates. So, all right, so let's see how this goes. To do the
Negative I.
of course, that's why it's wrong. Holy shit, doing so many wrong things today. So we're gonna integrate with respect.
Sorry, I was just like clarifying. You switched the x and the omega and the other one. Then?
Yeah, it's just
Okay.
because it's just because this function originally has t.
Oh no, I meant like on the other side, like there.
Yeah, so it doesn't quite matter. Like you can represent it in all sorts of ways, right? You can do the transform in space. You can do it in time. So this is the one like in time, and this is like one in space, and it doesn't really matter.
Okay.
But it's like math has so many like confusing things that are just like notation, but they're all the same. Great.
Agreed.
So just to make sure, I'm taking integral with respect to this. So I'm gonna put the negative I and t. Negative I and t on the bottom. Then we'll take this. I really should have done this one yesterday. This is the one that I didn't do, and now I'm regretting it. Now we get our constants, 2t I over here. Get e to negative I k t. Can't really do much about that. Then, oh, sorry, my bad. We took the integral. We haven't found the thing yet. So get t or sine of at negative. So on the positive end, we get e to the negative I k. We'll just write this as like a different thing, which is to the limit of infinite, and we'll get the e to a negative I a k, and the a times the sine of a. That
Aren't we integrating
yeah.
with respect to k?
oh shit! Oh my goodness! Thank you. I was like, oh, I did something wrong. Thank you so much. You're right. Okay, yeah. So we're doing this. Holy shit. In which case is also a constant. You can just do minus e to the positive I t, and then times that. Okay. All right. So now you end up with two i's, e to the i's. As we remember from the Euler's identity, which says that to the so e to the ix is equal to cos of x plus or minus I of sine of x. So if we substitute both of these into our equation here, we'll get that. So just to be clear, this is the Euler's identity. So we'll get the cos ax terms will cancel out, and then your sine will stay. So we'll get sine of ax minus cosine of ax plus sine of ax. So this equals just 2 negative I sine of ax. If we substitute this back into our original equation, then we get I, and then a will go to infinity. So actually, I don't know why a is going to infinity now. That's kind of useless info, but we'll run with it. Also, I'm sorry for using confusing t and x notation right here. So our I will cancel out here. Go for it.
Okay, so I'm just all of the negative infinity terms, e to the negative infinity tends to 0, negative e to the negative infinity tends to, oh wait,
Tends to infinity.
sorry?
I think the problem is that one goes to 0 and the other one goes to infinity.
Oh,
we can't
but
evaluate
the other one where it's divided by negative infinity goes to 0 anyway.
Which one?
Sine at over t.
But we're taking a derivative with respect to k, not with t.
Oh, with respect to k, not with t.
Yeah.
So yeah, I got confused.
Okay. Negative sign cancel out, and this will put positive root 2 on the top. So now we'll get square root of pi and 2. And then you get the t of sine of t, and just the limit e to a of sine at. So I think there are two formulas that we need to remember. I think one is if you take the limit of like sine to the at, and one is to cosine to the at. But I don't have my note here, so I'm just gonna check with Symbolab to see if this is correct. Interesting. Okay. I think I did something wrong. Let me just check my other note. This is gonna be. Let me check my other things. We did the one with respect taking a sine negative 2i. Interesting. Okay. Let's see what I did wrong here. I think I did the formula wrong. Fuck. No, I didn't do the formula wrong exactly. Okay. It's just one of those fucked cases because we're ending up with two discrete things. But great. This is just awesome. All right. So shouldn't have picked this problem. That was my problem. All right. Back to our original thing. It turns out that if you wanted to represent your sine wave as a Fourier transform, you get not only what you intend to get, but also the negative frequency, and you get a spike on the negative frequency and a spike on the positive frequency. And because we're dealing with continuous transforms, you end up with like two spikes that are represented by the direct delta function rather than like two just flat pieces. If you were doing like a discrete transform, then you will get like a flat piece that is the same width as whatever grid you're using. So that's kind of stupid, but okay. Coming back here, just gonna paste that in. So essentially, if you were to pick the to just take this guy here, see if there's a way to do this. I don't think there's any easy way to do this at all, actually.
Can we do an easy problem and then come back
Yeah,
to this?
okay, this is stupid. I should have not picked this problem, my bad. Okay. Today is just a lot of things going wrong for me.
Oh, good job.
I cry.
Okay.
We can do this one, which I think is okay. Again, this one I don't have anything to check against, but looks very cursed as well. And let me just make sure that any of this is within the scope of actually what's going to test just by looking at the solution and how crazy difficult it is.
I think he did this one in class.
He did
That
one that is
doesn't-
similar,
He does a lot of things in class that he doesn't expect us to actually.
right? So I don't know if we should do any of this. That I have doubts now. Like, we're obviously not expected to do the Gaussian, and he did this after the Gaussian. So now I'm like, okay. I guess we can definitely do the square pulse. I think the square pulse is reasonable. The one where we have to take the square pulse with respect to the origin. I think that's fine. Like, maybe he just taught us all of this Fourier transform only to be like, you guys are too rookie. You can't do any of the real world problems. And the only thing you can do to salvage yourselves is like by implementing this on a computer. So we'll do a square wave that's from negative a to a with a height of, let's say, also a. So 2a, like that. That would be a square. So this would be represented as, we first just have to write the initial function. So the function is at 2a when x is within like negative a to a, and it's 0 everywhere else. So when we try to apply the Fourier transform, instead of taking a derivative from positive infinity to negative infinity, we know that the integral of everything else, of everywhere else, is just 0. We can just omit this and take it from only the part where the function isn't 0. So negative a to a, and then we put I k t kx, and our function is 2a. I think this is the only reasonable one because this is actually a constant in the middle. So if we just take our constant out, 2a of a negative a, all right. So just to make sure I'm doing this correctly. When we take the derivative of the e, we get that you get negative I. Sorry, is it dk? Wow, I'm confusing everyone. When you get x on the bottom, we get negative I kx from a to negative a. Can we write this in terms of 2a of negative ix of e to negative I ax to minus e to the positive ix. And just so I don't scare myself again, I think.
Jesse?
Yep.
Since this is an even function,
Yeah.
could we
Take one side.
Yeah, could we do the thing where we integrate from a to 0 instead and double?
You
Like,
can
could
do that.
we do that?
Yes, you probably could.
Okay.
I can do one like that and see if it comes out the same.
You don't need to, but like
Yeah.
just
Technically
that would be
speaking,
easier
yes.
for me on an exam to perform.
Yeah, technically yes. So the Fourier series, if you run across like sine or cosine functions, you just know that it only has one of them. Sorry, if you run across even or odd functions, you just know that it only has one of the terms. So you would omit calculating the other term, and you can just times it by 2, your final result. And similar to before, this ends up giving us 2 negative I sine x. So we're going to do I sine 8x. We have a negative 2, we have a square root of 1, 2a, have a negative I1, negative x1, negative 2i sine ax. So negative cancel, I over I cancel. We can bring this to positive root 2. So we can do pi root a with a over here and our x sine ax over here.
How's that negative 2i sine ax?
We did it over here with the Euler's identity. Like this.
Okay.
And then I should have taken a screenshot of this and sent it to my computer, but we can check. See if this is correct. Oh, okay. This guy just expressed this in terms of something else. But I think we have found a solution, which is great. I think in the exam, if you don't write it in terms of like sine C, he won't deduct your mark for that. Because it's kind of not really expected. So we would call that we solved the problem. Hey. Okay, so another one that we might be asked to actually do is one that he said that we should take as homework, I think, where you have to find the Fourier transform of like something, the derivative. So we can try that, right? So we can, first of all, just to make this really clear, because it's easy to mess up on notation, just to be clear, our function fx is an underlying function, and then f prime of x is the one that we want to take the transform of. And this will have the transform of f omega, and we'll call this one like just something else. We'll call this like g omega, just to not confuse ourselves. So we'll say that g omega we can apply the formula, where hopefully at this point we don't have to look at it. Positive 1 to infinity. We take the e to the negative I k x of our f prime x and dx, just to check. Yep. So taking transform as negative and then reversing it as positive. If we want to integrate something, sorry, this is dk, of course, it's a mistake.
I have a quick question. If we have f of x and we want to transform of the derivative of f of x, why do we need f of omega?
We can change the thing, yeah. We can just write it as x. That's totally fine.
Oh no, I was really asking why we need to find the Fourier transform of f of x if
We don't.
We're trying to take the transform of the derivative function. Oh no, it's just like if we were to have found it, I would represent that as f of x,
okay.
just to not confuse it with g of x.
Okay,
That's
thank you.
that's all. That's why I wrote it there. And also, I think the Fourier transform of the derivative function will relate to the original f of x in some way, right? So I think one way for us to see it is if we just write both of them. So we can write also the Fourier transform of the non-derivative one. So because we're taking, go for it.
When we initially defined
Yep.
Fourier transformation, we defined f of x for the function and f of w for the transformation.
Yeah. It doesn't matter, right?
Okay, so we can, because the Fourier transformation, we never actually like evaluate it.
No, so
So it doesn't matter what variable.
it does not actually matter which variable name you use.
Okay.
I don't think you will take your marks for using the wrong variable name. Like essentially, they're just random variables. Usually, it's easier to represent something after the transform. So when you're transforming with respect to space, with respect to time, it's easier to write omega because omega will represent the frequency. But if you're transforming with respect to space, then omega would represent like the angular frequency, angular momentum, which I don't think is much more convenient. But usually in signal processing, you're dealing with like time data, so I don't think that would have a dramatic impact. Okay, so this is what we know, right? And we want to express g of x in terms of x, in terms of f of x. So we can identify that because this term doesn't have dk, we can take it out of the derivative. So in fact, we can write that this entire thing is over here, and remove that guy. iPad is too nice. All right. So now the only difference that we see from the top and the bottom is our function over here. So essentially something that we would like to do is like take, rewrite the second equation as, let's say, f of x over f of x, right? And equate that to this, which now we can, actually I don't know if this is advantageous, but we'll see how that works. We can substitute this one into g of x, and we can get that f of x. Okay, that's actually useless. What am I doing? Okay, I should really not be teaching this section. Someone else should. Who understand this better.
Unfortunately, none of us understand it. Well, I'm
Okay.
speaking for myself. I don't know, but
Then you're just unfortunately
I'm learning this for the
listening
first
to me
time right
until-
now.
Then you're just unfortunately listening to me ramble until we figure this all out.
that's all.
So the g of x will be equal to this. So now we get some sort of relation with respect in terms of f of x. And we have everything else written in terms of like f x and f prime of x, but because in the original question we only had access to f prime of x, so I would probably just rewrite this in terms of that. So we can write f prime of x and then integrate f prime of x. Also in the original question, it asked for f prime of a, so I'll just rewrite this in terms of a to be extra clear. So a, and then we take the dA, and then the Fourier transform of the original function can just be represented as the Fourier transform of I don't know how we would write this actually. I don't think he ever talked to us about writing this. In the Laplacian transform, we'll write like this, right? But I don't know if it's legal to write that we want technically the original function in here. So okay, so after the session, I'm just going to email him and ask if this would be correct, and see. Okay. But honestly, like, given whatever he's taught us, I think the only thing that he can really test us on would be the square pulse wave, which is important for you to know. And also, go for it.
Oh, I was just gonna ask about how you did the, how you got the final equation.
Oh, yeah, sure.
I'm just like,
This one?
I'm kind of confused as to why you integrated the bottom, but you didn't integrate anything else.
So it's because in this equation, this guy is the derivative versus these two guys are the original function.
Wait, are
So-
they both? Sorry, I got lost on why you were dividing them and stuff. Like, why
Yeah.
is that g of x?
Sure. So I just wanted to represent g of x in terms of f of x, and then I noticed that this entire portion is identical. So if I can represent this portion in terms of something that I already know, then I can substitute this equation into g of x.
So this is like if we don't know what f of x is.
Yeah,
Like,
no, we don't know what.
We're only given the derivative.
Yeah.
So that's how we, okay, that makes sense.
Yes. Yeah. So like this would be finding a general formula for the Fourier transform of this derivative. But honestly, I don't think he will be that picky. So maybe like this will also be acceptable. Like this will probably also be acceptable. Again, like notation, I'm not too sure. He didn't teach us this.
Don't think he cares.
Okay, cool. I think another one that we can try to do is like, I think the only things I can really quiz us on for Fourier is the square wave. And
Well,
then,
he said in class, like, he'll
this
do the sawtooth or step
Yeah.
function. Don't know
okay,
what those are. I know step is what we just did, but
Yes.
don't know what sawtooth is.
sawtooth. Interesting.
And then, well, that's series. He didn't really specify anything for transforms.
Oh, really? Okay.
That's what I
Dang,
have down. I don't know what does other people have down.
That's insane. Okay. Okay, that is actually insane.
But
Wow, okay.
Oh,
The sawtooth function,
yeah.
what's the
But like-
equation?
But it's a straight line, so I guess it shouldn't be
It's a
that
straight
bad.
line.
Yeah, like I
It's
don't
just
think
a
sawtooth
periodic.
is even
Yeah,
easy
like,
to
it's
represent
like-
in terms of.
Hey,
That's for the series, though. It's not for the transforms.
Oh, okay. I guess we can just.
And I think we did it in class.
Okay, so I don't think we
what's up, gang?
really have to care about this that much then. That's good. Welcome.
Thank you, Jess.
Sorry, I had so much trouble this morning. Probably just because I wasn't well prepared enough. So in terms of series, I found some questions. We can. So for series, you can represent things in terms of cosine and sine waves, or you can represent them in terms of one or the other. So because if you look at the unit circle with CAST, your sine wave is the same like when mirrored across the y-axis. This means that your sine function is even, and then your cosine function.
You got it wrong.
Oh shit!
It's the opposite way, yeah.
Yeah, my bad. Odd is the negative.
Inside and outside. Negative f of x is equal to f of negative x.
Yeah. Yes. Okay. Well, we'll make sure that I actually review this before I get onto the exam. So let's not get that confused. So these are things that express some sort of property about when you take the function of the negative x. So this would be negative f of x. And this guy you would just get the original thing back. So even function. Yeah, so even function should be a projection, should be a symmetry around even function should be symmetry about the x-axis, and odd function should be negative. And then odd function would be reflecting along both axes. So if I represent this in terms of icons that you might have seen before. This is like flipped that way, this is like flipped the other way. The Fourier series, let me just go screenshot my notes over here. Just to make sure that everything is correct. Did he go over the derivation of the Fourier series in class?
Yes.
Are we expected to know it?
No.
No.
Yeah. It's more of a
Just-
tool, I think, to model stuff.
Yeah. So just
Yeah.
making sure.
He was like, he did this whole thing. He's like, and that's a Fourier series. I'm like, great.
Great, thanks for you started the lecture.
Yeah. Like say this is a
Yeah.
Fourier series. That's how you divide it.
Yeah, that's how you use it.
Okay. Wait 1 second. Oh shit. Streaming private stuff on public YouTube. That's not a good idea. These are the exact same things. So
Okay, now let's use it. Wait,
over here.
take it easy, man. What the fuck?
Okay, there we go.
Don't go like this.
Alright.
Go like
Yes. Very bad. I don't like a single one from teacher system. She's okay. She's. The course is hard, so I hate her.
And I didn't screenshot the original. Okay, this is just me being dumb. at
What's
this
wrong?
point. No, I just didn't get the original formula as well. I should either have this written on paper or something. This is so annoying.
Don't worry about it. He just. He's a bad idea.
Pro series is correct. Okay, people on stream will be so annoyed. It's just like, you're not actually going to do anything.
I'm just curious.
So, just to make sure this is correct. I'll just write these 3 formulas and then we can continue after that.
For the most part, I think bathrooms, I've seen.
Okay, but no, please.
I know.
Yeah, that's, I'm telling you, 6 people got 100. 6 people.
You said 6, right?
So how do you got 0? It's the real question.
Wait, how many? Yeah, how many people?
Most of the 70% of the class past couple.
One of them was. Yeah, that makes sense.
Yeah, one of them
So
is-
if you don't count the 600s.
I don't know.
The past average, if you don't count them, is 30 something.
Yeah.
Yeah,
Actually, a lot of
if
people
you
got
take
within
it
like the 50s range as well, but like not. Not okay. When I say
Yeah,
a lot,
he goes
wanna
to
take a
every
break?
class.
More than
Yeah,
zero.
That
More
would be
than
nice,
zero.
And
actually.
also it's the
For
one
people on
was-
stream, I guess we can come back and like.
I think it's just Amanda. So hello.
Double check, double check.
Hi,
It-
Amanda.
I don't know how loud that can
Hi,
be.
Amanda.
Does anyone have an iPhone charger, by the way?
Yeah, there's one over there.
I'll steal it later, but like I will need it.
I also have one.
Is it? Yeah.
No, I remember John told me, like, I went to meet with him after the midterm. I stopped by his office once a week because, like,
Son?
yeah, besties. Actually, he's the coolest guy.
I love it, son.
Can we officially publish that class? I feel
This
like
is no, it is official. I'll tell you why.
I've already whatever because
So-
I need coffee and I don't know
Don't know what.
like
About
what
coffee.
I know that coffee tastes good sometimes, and
Just
it
get iced
also
coffee, guys. If
makes
you're not
me
I
go
can't have
fast.
iced coffee.
Why?
It makes the brain go fast. That's what I can tell you.
Huh?
Can you have chocolate?
No.
Very simple question.
You no like
I like this guy.
I don't know. I don't
Coffee,
know.
chocolate? No chocolate. Pass.
I don't know.
Wait, what do you? Why
So
do you
I
need
just
coffee?
drink coffee.
Sorry?
Why do you need coffee?
Because
It's a weird question to ask the
very,
university
very,
student.
very tired.
I have some chocolate.
I can't have chocolate.
Ah.
I plug it into my
Right,
coffee.
right.
Oh,
I can't.
it's gonna be
That's
called
faster
Fox
if
Talk
you
now.
plug it into the.
Yeah.
Wait, are there outlets here?
There are
No.
no outlets.
There's only one
anywhere.
over there.
There is the fire hazard we've got, and there's no other outlets.
You guys, you're in DWE, guys. Douglas Wright died like fucking 80 years ago. Like, this building was built way too long ago. You don't understand. Like, the fucking signs for WUSA in this building are still labeled FED, like Federation of Students, the
Oh.
previous name of WUSA. And this was like before we were born type shit. Like,
Yeah.
there's a fucking SNES at the door. Like one of the very first gaming consoles right at the door. Yeah.
The very first.
Okay, it's like, let's say 20th. Like, okay.
When Rem was called V2.
Yeah. No, even before that, actually, I'd say.
No, this is one of the oldest buildings. on
Yeah.
campus.
Isn't it technically U1? Or is that?
This is what it
This is
used to
E1.
be.
This is
Yeah,
E1.
this is E1, yes, but then they renamed it an honor.
And I think
That would make
CPH is E4.
That would technically make the QNC like E12.
Why?
Wasn't it like
Why are E5 and E7
It would be
in
E9
the
because
same
E7
building,
is
but
the
E6
university. I agree,
E6
but the
is
joke
like
is it's so
outside of
advanced
it.
that
I
it's
don't get
wrong.
how that
Why are
works.
E5 and E7 part of the same building?
Because
I
E7
know-
was
I-
built after E5.
And
Yeah, I think
E6 is in
E5
between.
E5
Oh,
is
that's
just-
an extension.
They extended it, but the extension is bigger than the original building. So they
And
built it-
E6 is somehow just in the middle. Like it's the bridge, I think. I think
It's
E6
No,
like
no, E6 is
outside.
the
No,
next
E6 is
building.
behind it.
Yeah, it's for chemical engineering.
I know,
yeah.
no, I know. I
And
was just
E6 is
wondering
newer
why.
to E3 and E2 and all that, right?
Also,
No,
why
E6
would
is
they
on-
need
E6 is
to
behind
move,
it.
like the
it goes
extension?
E5, E7, and then E6.
Yeah.
It's really stupid.
Everyone
E6 is
just
right
calls it
on.
E7.
I don't know why they didn't just
Yeah.
call it E5 expansion.
Because the expansion is bigger than E5. So it
Wait,
would
that
have been
doesn't
weird.
make sense either. Though, why can't they just call it?
I think they just like
E5?
fucking with us.
Yeah, yeah, that makes sense. That makes sense.
Is there an E4?
CPH.
CPH.
Oh.
And this is E1.
And then is
E1 and E2. What's E3?
There's an
E5
E3
is
building.
attached to E7.
Yeah.
Never mind. No, no.
Okay.
Yeah,
RCH.
Yeah.
RCH.
There's too many fucking engineers.
Thank God.
RCH is
I
a
love
bunker.
something.
RCH is the weird bunker building. Where we
I
had.
would take
Yeah.
a math
Engineering
exam in that.
Where we had
It's
one
like
thing.
1/4
on
of
the
all
long axis.
Oh my god, I fucking hated our RCH. Like we had our
I mean, not
Not including
computational
math and
methods
computing.
thing last
Just
year there, and it was just so bad.
The QNC alone was like $16 billion or some shit.
Yeah, but
I'm
the
sure the
difference
lab
is
costs like most of it.
Yeah.
Yeah. I always
Honestly.
have the have you guys ever been to the IQC?
No, but I have a lot of
It's
friends
so
who are.
pretty.
It's crazy, bro.
Yeah, it's so pretty. I took like 10 pictures, but like it's so pretty.
How'd
in
you
there.
get access?
Because I had to go to
Oh,
what's
I
his
just
face?
stuck in
The
Wilson.
physics. Yeah,
Chris
Wilson.
Wilson.
Chris
It's because
Wilson.
he gave me a low mark on my final, and I'm like, oh, I wonder why that is. And then I realized I lost 20 marks because I did like
Okay.
elastic motion instead of inelastic motion or something like that. So I
Oh.
lost like the whole question, even though I wrote like a solution.
And then I went with
So-
her and explored while she was like talking.
It
So
was
it's with
fun.
Amanda and Valentina who are watching on stream.
Okay. Hi guys.
Hold on, what's that?
Hello.
What are you looking at?
Jesse's just powering through.
She's just getting ready.
Yeah, I'm just writing down some like practice problems that we
When do
can
you
do.
guys want to take our lunch break and go to Timmy's?
I mean,
What time is it
1:40. It's
now?
1:40, so.
No, see,
I woke up less than 2 hours ago. Lunch.
Bro, I'm always ready for lunch.
Same.
Like even if it's like 8 a.m., bro, I'm down, bro.
tell me it's dinner time right now. I'll
Yeah,
go.
Well, 7 hours ago. Be built.
Fuck.
Wait.
You woke up 7 hours ago,
Something
Yeah, still
like
got
that.
10 hours.
and then you started
Guys, I
studying.
didn't wake up yet.
Guys,
That's
No,
good.
I haven't started studying.
Oh, okay.
I went to bed at
I
6
count
a.m.
these workshops as my study hours.
Me too.
I go home and then go sleep.
I was up all night, and now I know all the
Yeah, no.
reactions and stuff. Fuck chemistry, man. Fuck English. English is taking the most time this term. Out of any subject I'm taking, English
Which one
109
did you take?
Because
online.
no one did SPCOM 100.
SPCOM was so good.
Because I went
I
to-
wanted to get in. They wouldn't let me.
No, I wanted to get into 223. They wouldn't let me get into 223.
Because
And then,
yeah. This public speaking one.
yeah,
Yeah.
Yeah,
because
it's
bro,
because they're stupid.
there's no effort required. You just have to be confident, and like that's so easy,
You
bro.
get your marks. bro.
Yeah, it's for free. So I
Yeah.
applied to that.
I
like,
public speak for fun.
literally like yesterday.
Yeah.
You know, and like, oh, it's clashing. Suck my dick, bro. Make it unclash. You
I
offered
think
it
we
as one
can
of only
finish
3 courses
this.
I could take.
Section in about like 20 minutes, and then we can go for a break. Do
Sure.
we want that?
Sounds good.
Yes.
Finish the section, then go to lunch. Sounds like a plan.
Also, before you start, guys, it looks scary, but I promise you, 4 year series is probably one of the easiest things on the book. Yes.
Sounds good.
Not the transforms. Those are hard.
Yeah,
This is fun.
The
This
series.
is literally a game. This is literally a method to just they'll give you a function, you graph it out quickly, and then you model. It's so nice. I promise.
So even though there's a lot of formulas
20
on
minutes
screen
sounds
at the
good.
moment, I'll just point out that like they are all ways for. I'm pretty sure I copied down something wrong because I shouldn't have two
Separate ones.
collections of close. Yeah, I should have.
There's
the main one, I
think.
The odd function looks wrong.
Yeah, it should be cosine. Wait, the odd function looks wrong.
Yeah, because it's odd, and you can't do the 2, like 0 to L, and then multiply by 2.
What do you mean?
On top left.
Yeah.
Yeah, you can't do that with sine, can you?
You can.
Isn't it supposed to be 1 over negative L? Because with sine, it's odd, so you can't like.
Sine's an even function. Or, no, wait, yeah, you're right.
Yeah, because of both. They're actually.
Okay, I guess
I'm not
we
sure.
can go for lunch right now.
Oh.
Technical difficulties. We need to figure out the series. But isn't
I'm totally not.
isn't it the sine and cosine terms are all added into one Fourier series?
Yeah, 1 second.
Sorry. That's how Canadians say sorry.
Sorry.
Yeah, it's so weird.
That's if you get to like the really Canadian part.
No, like
If
fucking
you're fr-
Kitchener, I promise you.
Really?
People in Guelph,
That's
they say
so
bago. You know, girls in fucking people say,
Bago?
I swear,
I
it's so
played
funny.
with
What's wrong with
someone
Wall?
like that.
I think this is
Oh.
for.
Listen, Robbie,
Alright.
you're a cool
Let me
guy,
see
okay?
how-
But that doesn't mean I have to respect where you're from, bro. Like, I can separate the artist from the music, you
Let's be
know?
honest, there's nothing in Guelph.
Yeah. No, but like, I don't know.
Actually, the nightlife ain't bad.
I heard people go there and club and
If you-
party, yeah.
If you've ever been downtown Guelph, it's pretty sweet.
Mm. Yeah.
There's also a country bar up in the north end that has a mechanical pool.
So that must be fun then. Apparently there's like entire competitions for that shit or whatever.
Yeah, they do competitions for that.
I don't know, North America is so weird, bro. I still haven't gotten my head around how this place like functions.
Have you guys ever heard of
I feel
that
like
thing
it
called
doesn't
like?
to a certain extent.
Have you guys ever heard of that thing called Canadian talk?
Copy
And
down.
it's like
the
we talk at a high voice until we get to our point, and that's when we.
And then
go.
they no, and
Like, have you
also
ever heard of that?
yeah, and I think I've noticed it actually.
You
And
could- yeah, it's
also
probably-
white boys like they grovel their voice. Like, yeah, bro, I'm headed down there tonight.
Yeah.
Like, why do they talk like this?
Yeah.
You do it too, bro. Don't look at me funny, bro.
Yeah, sorry.
Fucking Canadian people, bro. Yeah, bro. That's, no, like I'm not even saying
Wait,
like,
but
like
what did you mean about like the high?
Oh, like if I'm talking like this and I want to say my point, I won't say my point until I get to the end.
no,
Hear
that's
it?
just that's an
Point. It kept going high until I got to the end. Slow.
That's
Is that not like a
It's-
normal thing?
No, it's Canadian talk.
Oh.
Yeah.
No.
Wait, give
Yeah.
us so do it again. Do it again.
So if I talk like this and my voice keeps going high, I won't get to my point until my voice gets low. Do you hear that?
Wow, that's
Yeah.
That's not a Canadian.
Apparently it's
that's
a
not
Canadian.
only a Canadian.
Apparently, people say it's only a Canadian thing.
They're liars.
No, that's just
TikTok.
how
Wow. My sources. Sorry, guys. I learned everything.
My sources, I made it the fuck up.
I have
Just
just trust me, bro.
Trust me,
Just
bro.
Your sources
Yeah,
are
I
Chinese
feel like
propaganda. Don't believe it.
Hattie, if you went to Toronto, you would want to shoot yourself. The way
I
people talk there.
go there often
Sorry,
actually.
what'd you say, Jesse?
Often,
we
quite
fixed-
Wait,
often.
what parts? What parts?
My girlfriend lives in New York, so I spend a lot of time
North
in
York?
Buddy.
Midtown, mid York.
Oh,
You're
okay.
talking Jesse?
Yeah, no, I think I just fixed it. I think I just wrote around this should be cosine, not sine. So basically,
Oh, yeah.
this looks very scary, but our goal here is to rewrite our functions in terms of cosine and sine functions. So if your function happens to be even, then you can use only cosines. If it happens to be odd, then you can use only sines. And so we would omit the other side. And also, same trick that Oscar mentioned earlier, you can just find it from in the positive side and times it by 2. And then we don't have to find it for the other side as well. Versus if we have to find both sides, i.e. it's not even or odd, then we'll have to find it within the whole range. And then we have to times it by whatever your range is.
Wait.
The 2L is confusing.
Yeah, isn't that trick only for it's for even functions, not odd, or is it for both?
It's for both, because if you just find it for one side, you can, like, the odd function has the property that it is odd on the other side, right?
Yeah.
So it doesn't quite matter, like what way the symmetry works. It's still symmetry. I'm still like
So we're
flipping
not
my
looking
function.
at like negative area as negative area and then they cancel out. We're looking at, or like
Yeah, that's
they're
my
not getting
question.
subtracted. They're being like, you're just looking at absolute area.
Oh, I see. That's a good point, but I think I'm not too sure actually. But this does work.
So like just memorize it, basically.
Like,
If you're really that worried, guys, you can do it manually. You just go negative pi to 0, negative L to 0, 0 to L. But for now, we can just try this. It looks so much nicer. We'll try it now. We'll see how it goes.
so I think L is just like an arbitrary, it's
Yeah.
just an arbitrary interval that will eventually cancel out. So I think with the Fourier, go for it.
Is it always periodic, the things we model?
No, so you can model piecewise functions as well that aren't periodic.
Cool.
If you have a periodic thing, then most of your terms will actually cancel out, and you will get just like 1 or 2 specific terms that have the specific frequency that you want. So like, if you run into actual problems, actually we should add one that's like just f of x of cosine 2x or something, just for sanity check. We should do this one just to make sure our methodology is correct. So when we come across functions, we can first identify if they're even or odd so that we can take a shortcut potentially. So the first one, it looks pretty odd to me. The second one is the square pulse around the origin. If the question tries to be tricky and says that it is from 0 to like 0 to a instead of shifting it that way, you can either do your Fourier. You can either shift your entire function such that it's centered around the origin, and then perform your Fourier transform, and then shift it back, or you can use what's called the even or odd extension. So you can, instead of saying it's 0 on the negative end, even though we don't care about that, you can just say, okay, great. I'm just gonna say that my function is like I'm just gonna make some numbers up. I'll say it's negative 2a over here, and I can make this odd, or I can say it's negative 2a here and make this.
Makes sense.
make this odd, or I can make this even. I can't. I'm
No,
supposed to-
No.
no, it would be odd.
It would be odd, right? Okay, yeah, it would be like that. Right, so that and that would be a reflection around. This is even though.
No,
You drew it wrong.
can I?
Yeah, wait, what did I do? Shit. But A has a sign though, right? I'm so confused. Sorry for that.
For -2a, wouldn't it be? Where's the Thank you. And then if you set it to -2a elsewhere, it would be that.
Oh my god, I'm so sorry. A is not a variable. A is a constant.
Yeah, but if a is a constant and it's negative,
Yeah, no, I thought it was a
When you said we could shift it, you're saying that we could just change it so that.
yeah, or we could have it be
Like,
yeah,
you can
interval
literally-
-a/2a.
Yeah.
Or a/2. So that would be moving it over half a step on the
So you
given
would be finding
interval
the Fourier
0a.
transform of like x.
So when
so
we
to
do this, we can basically change where, as long as we change everything, we can change where the interval is.
Yep, because we're trying to
solve it.
find the area.
Right, and then it doesn't matter where it is. Okay, makes sense.
You can try to find the Fourier transform of the shifted function, and then like convert it back. That's an option.
Okay.
But probably wouldn't recommend this on the exam just because it's more error prone. And the way to find the even or odd extension is by using the formula that it originally had. So you want to have the positive side is just the original function, and you want the opposite side to be f of minus x, in which case is minus 2a. And you would put this here instead of 0, so this would be the even extension. Versus the odd one is you would just put the what f of x is equal to by shifting your negative sign on the other side. So you will get 2a for odd. I think that is correct. Of course, that's why. Okay, makes sense. So for function that is piecewise, we can deal with it in terms of like two portions that we can deal with separately, and then oh, by the way, for after you found the Fourier transform, it is only valid on the positive side. It is not valid on the negative side of the function. So your Fourier transform would only apply for 8, 0 to 8. And similarly, you can just like for your piecewise one, you can divide it up and be like, okay, I'm gonna cut this function into half. The top one can just be my like if you want to deal with it in the even odd function way, you can find the top one, the Fourier transform, by using either of the extensions, and then find the bottom one, and then just add them up. Or you can use the full formula, which is why the functions that apply to all functions. Sorry, the formula that applies to all functions is more useful in my opinion. And obviously, cosine would be even.
Sorry, when you say extension, does that mean like what you have to do to convert it into even or odd?
Yeah, so you're
Okay.
just assuming that the other side looks like that, even though it doesn't. You can also avoid this by using just a regular function.
Wait, why can you just assume that the other side looks?
Because whatever Fourier transform you end up finding, it will only hold valid for the positive end.
Why?
Because if we disregard if I match a bunch of sine waves, right, and they match up to a shape like this, where this is the x-axis, then if I only care about the top part, then essentially I take this portion, which is valid. Versus if I also take the bottom part, then this portion is not valid.
So then you're just like making the other side equal just
just for
calculation.
yeah, just for calculation. Just imagining that is the case. You don't even need to like end up using it.
So do you have? Is that why you? Oh wait, do you have to divide by 2 then at the end, or?
No, because you're just using the symmetry for finding the solution. You don't need to divide by 2 because the 2 affects magnitude. So if you were to divide by 2, right, your wave that you found will become like less intense rather than just being on one side.
So the final answer is just not going to actually take into account the negative part at all,
Correct. Yeah.
even though you're calculating it with the negative.
Yeah, so usually Fourier transforms only hold for a certain region.
Why even extend them?
You can just use the regular function if you want. You can use the regular formula if you want.
Are we just extending to simplify?
Yeah, you will find the same thing if you just use the regular function.
I guess I'm just like confused why you can add stuff in but not have to take it out later.
Yeah, so basically by adding stuff, we're invalidating this part of the function.
But you don't have to take it out later. Okay, sorry, I'm
So
confused about that part.
because your function is already because both sine and cosine, like the way that sine cosine waves work in on like a piecewise thing is if you actually have a step and you want to model the step, unfortunately sine waves will exist everywhere and cosine waves both of them will exist everywhere and they'll be like just canceling each other out. So to make them cancel, you want the even property. So you want part of it to be even, part of it to be odd. So you want the even side here. You want the even side here, and then you want the odd side here. Right. So let me just be clear of what I'm talking about. So you want one function to kind of model like this, and you want the other function to kind of model like this, so that in this region, your cosine and sine. So in this region, you will get a lot of height. So that's how you can model a step function. So if you want to like make use of both sine and cosine, so questions usually will specify like find the Fourier series for this, but the question can also say find the Fourier cosine series for this. In which case you will use the cosine extension to you will use the cosine one to find the even. You will use the even extension to find the cosine series, and then if you were to be asked to find the sine series for this, then you will use the odd extension and then specify that it only holds true for x is greater than 0.
Okay, I think I get it. So the dark purple part is
like
what
how,
the added part should be equal in magnitude to the part that isn't shaded there.
Yeah, so I mean I should redraw my red, right? We can model something like this by putting sine cosine in this opposition state.
Wait, if it's like that though, then you don't need to multiply. Why don't you need to multiply it by 2 to find the area?
So what multiplying by 2 does is it extends your thing by 1 more, right?
Wait, you're only trying to find the area of half of that.
No, I just only shaded half.
Oh, okay.
Like it will be the whole thing, but I just only shaded half of it.
And then
on the other side, like this will also hold true, right?
And then okay, so you're saying the extended part should cancel out, and that's why you don't have to subtract it later.
Yes.
Okay, I think I understood it better the first time.
Okay, that's all right.
Sorry, thank you.
No, it's okay. It's okay. So we can start by finding one of the easier ones. We can start with this. Okay, just making sure I'm not making any sort of mistake. gonna identify this as an odd function. So we have one formula for how to rewrite the function, and we have one formula for how to find the an inside of the function. I will write both of these down. And then my an should be equal to L over 2 of 0 of x and sine n pi x L of dx. So I need to replace my f of x with x to the cubed. And I know this looks absolutely horrible to be taking our horrible derivative. All right. Do people remember how to integrate at parts? I said that I wouldn't have such a thing. Okay, so what I'm gonna do is I'm just going to change this to x, so we don't have any more integration by part in the rest of this workshop. But to be clear, you do need to actually know how to do it. And we'll just do one iteration, which is super simple. We'll call this m. So m prime is equal to 1. Call this n prime. So n is equal to n pi of L negative cosine. So just to be clear, this is an. So an is equal to L2 of, we do mn, so negative n pi Lx, and then we subtract by the integral of the bottom two, so n pi L cos of this. And this is just n squared pi squared L squared of sine n pi x L. And this goes from L to 0. So L to 0. So in this case, we end up with 4 terms. We get the n pi of L of L times cos of n pi L minus the 0, because this one has x in it. The 0 just gives you a term that is 0. And then for your other term, you plus the one that has L. So sine n pi L minus the same thing, but sine of 0. So as we know, sine of 0 is always 0, so this entire term is 0. So we only care about these 2 terms now. We cancel out the L, so we get cosine n pi over here. We get sine n pi over here. What does that mean, right? So on the unit circle, we have n pi's at this point and that point. So this point has coordinates 1, 0, where 1 refers to the cosine, and this refers to sine. And on this point, we have -1 and 0, where again, the cosine refers to this side, and sine refers to the side. So as we see, sine of n pi is always 0. And the cosine of n pi, it depends on it's -1 or 1 depending on which side you're on. So when when it's even, when n is even on this side, we have 1. When n is odd on this side, we have -1. So we can express this in terms of -1 to the power of n. So now we successfully simplified our equation into having only one term remaining that is actually useful. We can write our L over here and -1 n over here. So one of the L's will cancel, and we can incorporate the -1. We can incorporate the negative into the -n, so we can get n pi 2L of -n n plus 1. So now we found an. We can substitute our an into the original equation. So we get f of x is equal to the an term of n pi 2L and sine of n pi x. So this will be our answer. And sometimes it's easier to take out everything that doesn't have n onto the outside of our function. So I'm just going to do that. It's not consequential. You won't lose marks for not doing this. And just to make this look nicer, I'm going to make this. Should be pretty straightforward. Okay, let me know if I should like go up or down. Oh, I just realized I haven't ate all day.
Go eat.
Eventually.
Yeah, that's what I was thinking.
No,
about.
just do now. Like,
No?
it's 2 o'clock. Like, we've been working for like almost 2 hours.
Okay. I don't know. I think we started at like
Like
30.
1:30 fine, but like, I mean 12:30, but like still.
Okay. Cool. At least we got through like the concepts of Fourier transform and series. It's just practice from now on. And then we have the Laplace transform, which is also just like a lot of practice. So I just picked like 4 problems for that. Series solutions, pretty simple. I think these are like pretty simple things once you can do this kind of stuff. Like this is not difficult.
Yeah.
Okay, but what do I even get to eat? There's nothing good.
Go to the plaza. Like, you're like right beside the plaza right now.
Okay, but I'm only comfortable doing that if we all take a break. So.
You're only sorry? Who else wants to go eat?
Bro, me. I still haven't ate since yesterday.
Same.
Like-
I need breakfast. Wow. Yeah.
Why are you guys eating?
Bro.
It's not good.
Bro, after we went home, firstly, I walked out, the sun's gone.
Yeah.
That was weird. Anyways, I walk out, we get home. I get home and then I'm like, okay, it's time to cook for me and my roommate. My roommate's like, bro, come EV3 study. And I get anxious. I'm like, okay, I don't want to be late, blah, 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 because I haven't seen them in a while. So, okay, fuck it, I'll just have ramen. So I get one of those bulldog ones, you know,
Oh,
Yeah.
not bulldog.
and I crack the fried egg on top with some carrot.
Oh, that sounds good.
It was okay. It was fine, but like it's not food, like,
Yeah.
you know.
It's not a home cook.
I have it, and then like I'm like, bro, I can't do this anymore. Like just live in general. So I just crashed on my bed. Like I fuck food, fuck drinking water, fuck. I was like, fuck this, خلاص, it's done. So I get in my bed. Out of nowhere, my roommate's home. He's like, how do you wake up? What the fuck? What? Weren't you in EV3? He's like, bro, it's been 2 hours. He's like, listen, you need to go back to EV3 because the other roommate's waiting for me there. So let's go.
Who's your roommate again?
Ahmed Ramadan, Egyptian guy, and Madvi and Sam. No one's an edge, just me. Anyways, so what ends up happening is you can tell how fucking hungry I am. What happens, guys? What did I do yesterday?
You went to sleep. Just go eat.
No, but I'm so tired of having Tim's. That's all I've been eating.
I'm saying yalla, I potato on the
Bro, I want
Or
rice. I
shawarma
want
plus.
rice. I want kebab. I want
Kebab shack.
Aziz.
No. Guys, support local businesses. Eat at Shawarma Plus. The owners are from my home. They're from my hometown. Like we grew up
Okay.
10 minutes away from each other.
Kebab shack is good.
But yes, as long as it says shawarma place that you're eating from is Shawarma Plus, I'm happy.
Yeah, Shawarma Plus is good.
Yes, support the
Their-
owners. Get
their
Jawad
baklava
style or
is
Mo
good.
style. Huh?
Their baklava is pretty good too.
Baklava. The Turkish called baklava. We don't support that.
You don't support that?
No, we don't support calling it
Good to
baklava.
know.
Unless you're Greek, then it's fine to call it baklava. But otherwise, it's baklava.
Balava.
Baklava. You can say baklava. I'll allow it.
Baklava.
Thank you. Baklava.
Baklava.
Yes. Otherwise, it's a crime. Unless you're Greek, then it's fine. Because,
Understand.
different geopolitical reasons.
Yeah.
Anyways,
Okay.
I'm sorry, were you writing them with Jesse?
No, I just copied down the formula, that's all.
okay, so
Okay.
Wait, did you guys catch this part or should I? Okay. Do we want to all take a break for
Yes, you
15 minutes?
For however long you need to.
Just go get
Something.
real
Go
food,
eat
Jesse.
something.
Go eat.
There
I'm not-
people stay.
No, you have to eat something because your diet it affects everything in your life. If you're not eating properly, you're gonna die. Like
Yeah.
I'm serious. Like I'm serious. You're not
I
gonna be able
have
to take
food
much.
that's cooked at home though. Like I have
So just run home and get it.
All
If
right.
you want to eat that.
I'm getting
Sweet.
Aziz. Anyone is more than welcome.
Shawarma Plus, yeah, it's the same price.
Laziz is more greasy.
Exactly, I like the grease.
I potato is better than Laziz,
I-
honestly.
I support Shawarma Plus.
Okay,
over
guys.
Shawarma.
Well, shawarma plus is better
Plus
than.
is in the plus.
Look, I don't
It's next to
go
Aldi's
to I
kitchen.
potato for the shawarma. I
Yeah,
go for the
it's
plus.
a sandwich. I like this
What
kebab
is
thing.
I potato?
Yeah.
I've seen it, but I've never been there.
It's Laziz but better. Is the way I.
I'll go with you if you go there.
Guys, like, you go Shawarma Plus and you get the rice bowl. It's like actually basmati rice. Sorry, basmati. Sometimes I have to force a white accent so people can understand.
I understand.
Yeah, it's like actually like you can actually feel the rice. Whereas when you're at Laziz, it's literally like short grain mush.
I don't think it would be
What?
easy.
Yeah, it's always a short grain.
That's what I'm saying. Like they don't, bro. You gotta toast your rice in ghee first. Dehydrate the fuck out of it. Add boiling water so that it boils quickly. Then that way you don't leave enough time for the rice to absorb too much water.
Yeah.
Guys, come on, making rice is an art. You have to master it, please.
Are you gonna go with them together?
Aren't we all going, gang?
Are we all
I think
going?
so. I don't know.
I'm not
have
going.
food.
I ate already.
All right.
Can,
Then
can
you're
I really
the-
spend more
you're the
money
stuff
on
guardian.
food?
Sure.
Oh no, I should told my mom. I'm like, yo, bro, I have nothing. I'm like, the bank limits. I'm almost at like $90 left on my credit limit. Actual funds are gone.
Yeah,
Listen,
you coming, Catherine?
I don't know. I shouldn't spend more money on
I'm not gonna
food.
go.
Son, I think
I'm
you're
not.
giving me I can't be asked to go anywhere vibes.
My parents came to my house yesterday. They saw my fridge and cried. They're like, okay, we're going grocery shopping. So then I went to dinner with them personally.
bro,
Oh, that's good. Sorry. Grocery shopping. is good.
is everyone going?
Well, no, someone has to
I
go
think
down
Natalie
before.
said.
That's what
I could stay too.
I don't know
Where are
where.
you going?
I think
Wait, what is
Plaza.
that? Is it my molecular thing?
Yeah, it's supposed to be. My friend gave it to me, but guys, this is trash. Don't buy the
Yeah,
one.
I thought it was like takeoff it or something.
Well, this is a Lego set, bro. It's not my
Oh, exactly!
Yeah.
Oh my god.
I'm not.
it's
I'm
so
getting the
nice.
nice one. Fuck
Do
this.
you know how to assemble it?
No, no.
Oh, I can teach you. Because I have the same.
No, I know
shoes.
how to connect parts, but I don't know what the parts are.
Oh,
Oh.
yeah. Can I see it?
My friend gave me like one of the good ones that I approved.
Yeah, no, this is. I have to give it back too, but I think I'm gonna give it back today actually. 'Cause I'm getting the nice one. Fuck that.
Yeah, no, you should. Amazon.
Yeah.
The nice ones with the
It's like
balls.
$30 or whatever, right?
Yeah, actually the one
Yeah,
that
mine
we
was
got
30.
was like $40 and it's shit.
Inshallah, it's 100. I'll pay 100. I don't care. Like,
Yeah.
Whose hummus is this?
It's not hummus.
it's
not hummus.
apparently Portugal.
It's your food.
Okay.
Isn't it?
It's my
I was gonna
oranges.
judge. I was gonna judge like.
You want to hear a fun fact? You know how it's called Portugal in Arabic?
Yeah.
Every time of a country called Portugal. And no, it's not a joke. That's actually
Really?
the same word. Yeah.
Damn, okay.
It's because when they invaded, they're like, this is the land of the oranges. I'm serious.
That's actually cool.
That's kind of smart.
Yeah.
I like that.
Fun fact.
They named the whole country after a fruit. To be fair, Ivory Coast is the thing.
I feel like everything should be named after foods. Nothing should be named after people.
There's just one Asian country where people refer to their mood via vegetables or like fruits. They'll be like, "Oh, you are like pineapple," and then everyone just understands. Like, I don't get it either.
Do you not know what feeling like a pineapple is? Imagine.
Bro, I feel like a pineapple.
I feel like a
every day.
pineapple every day. That's what it's
Yo,
like.
pineapple's a fire ass fruit. Why are y'all talking
It just
shit,
hurts
bro?
your tongue. If
Nah,
you,
nah,
if you chew
nah.
for too
This
long.
is weak stomachs. This is what I'm
I
talking
know.
about.
I can't.
This is what growing up in Canada does to you, bro.
That is growing up in Canada. But I do have the immigrant. Wait, I actually want to play this game with you. Guess my ethnicity.
I have no clue. I've been staying. Okay, if you want to be honest, you want me to be honest? I've been looking at you. For
Yeah,
like
I know.
36
I know.
hours
You're
now,
guessing.
and I have grown up
I'm
beside
just
this
trying to guess.
I know.
Based off
I've
the
been-
last name.
Wait, what's your last name?
Kazimi.
Spaghetti.
Oh,
It's
shit.
like-
What?
Afghan.
Yeah. Wait,
I
you're
was
not
like-
supposed to give it away.
Yeah,
No,
That's
I
your last
was
name?
thinking either based off the last name, probably Afghani, maybe Iran.
Oh, yeah.
Yeah, basically like Pashtun people, like Persian. Yeah.
Yeah, no, because it's not Pashtun. It's my parents are
Sorry?
Hazara.
I what?
Hazara.
What is that?
It's not where. It's whom.
No,
It's like a different ethnicity.
Yeah, no, I understand. Yeah.
Yeah, it's a minority group.
No, Kazimi's easy. Kazimi's easy.
Yeah, no,
It's
people
just
think
it sounds Arabic, but it's not Arabic because I speak Arabic, so I know it's not
You
Arabic. So
know.
what's my only option left?
Farsi. Yeah.
Yes, that's what I'm
You know,
saying.
it's funny because people think I'm Asian, like half.
White, half Asian.
white,
You also look
half-
Latino.
What?
You also look Latino. I fully believe you told me you're Mexican.
Yeah, or
Yeah, I
like
would have believed it.
yeah.
you fully look
People
Mexican.
see my last name, they think it's Japanese. And
I
I'm like, how does that?
I don't
I
know
know. I don't see that.
What's your last
People
name?
So-
thought
Kazimi,
it's Japanese,
K-A-Z-I-M-I.
but I don't
So
know if
do
Japanese.
you eat? I don't know how to say it. It's like pulao or
Oh, Palau.
palau. Yeah.
Yeah.
That's just crazy. I made it the other day. It
Really?
was banging.
Oh wait, okay. What did you put it in?
I have okay.
She's
So
gonna
okay. So
Wait,
my-
can you tell me what is it?
it's like a rice dish
Rice,
with
it's a
like
rice
very
dish.
soft meat that breaks apart in your hand. I have a pressure
Oh,
cooker
That's
at
good
home.
stuff.
Oh,
Yeah. I had some beef chunks. So I had like a strip of beef. I just chopped it up. It's
Yeah.
whatever I had, right? So it's kind of an Arabic inspired
Yeah.
pulao, but I'll tell you. So I have rice beef. So I boiled the beef in my pressure cooker. After browning it with, I have whole spices like dried lemon, cinnamon sticks, bay leaves, cardamom, and then a whole bunch of powdered spices with a fuck ton of onion.
Yeah.
I got it really tender. And then we took the rice and then we toasted up the same spices and I put raisins in.
Raisins.
Of course, I don't miss
Yeah,
raisins.
yeah.
The only
yeah.
thing I forgot to use was carrots because I was out of carrots.
That's
Yeah.
actually called Kabuli Palau because it's from it
Kabul?
originates Kabuli Palau because it originates in Kabul, which
Yeah.
is the capital.
Yeah, it's good. It's very good.
so good.
Yeah.
I didn't like it as a kid, but now I like it.
Now as an
That's
adult, bro, it's the
really-
craziest.
it's the best.
It's my
thing.
favorite
It's
rice dish
good
in the world.
I never make Afghan food at home. Like here, I make it. I eat it when I go back to Toronto, but I don't make it here because
Yeah.
it's too much work.
Listen, as a person who makes my ethnic food all day, every day, you just keep doing it until you realize there's shortcuts.
Yeah.
You don't like listen. People try to especially here in Canada. People like talk about authenticity.
Yeah.
Who the fuck are you to tell me what's authentic and what's not? No one is allowed to dictate what my people eat and
I
doesn't eat.
agree. Yeah.
Right? So you make it how you want to make it, and if some things you feel like might save you time, do it, bro.
Yeah.
The flavor. Okay, here's that Arabic
The
wisdom.
flavor is still better when you make it.
Yeah, but like it's the same base flavor, so you're gonna get it either way. Another thing, Arabic wisdom. So, like you know how, so maybe like 100 years ago, women didn't work as much, right? 100 years ago, they're like stay-at-home wives. So the idea is that we have this saying is that women would get so bored staying at home all day that they're like, might as well, if I'm gonna cook, I might as well make the most crazy ass complicated dish of all time. You know? So that's why a lot of our dishes, when you're like you and your friends they're talking about them, like your friends from the same like cultural background will be like, oh yeah, but mansaf takes so long to make. It's like, no, it doesn't. You know, mansaf, our Jordanian friends act like it takes 8 hours, but wallahi, I can make it in 30 minutes flat. It'll taste just as good as any other mom Jordanian mom's mansaf. Bro, it's just half. They just like to say, whatever, bro. Also, I like this guy. This guy, silent assassin. Didn't say a word. Then she says her last name is like Afghani, and then didn't flinch, didn't think about it.
And leave.
That's
Drops the wisdom.
He knows his shit.
Yeah, okay. You guys should probably go get food now.
The same
You
last
should,
name.
but like that requires me
Where you
walking
from?
to the plaza.
Of course.
Nice.
Yeah.
You could just chill here.
Like,
with
that's
Vietnam.
cool.
Are you gonna go?
I don't know. I feel like I need to go on a
Please, you
walk.
can leave
Okay,
Otherwise,
go.
I'm going to die.
Yeah.
I understand Hindi because most of our media comes from India.
Yeah.
But,
Wait, so Gary, do you speak anything other than
it's been a long time.
My first language was Farsi,
I understand, yeah.
and then I went to
It's
English
pretty
school.
cool,
and then
like even in Dubai, my
So like,
my
I'm
coworkers
trying
are
to speak it
Indian, like,
again, but I
40-year-olds.
have the language.
And whenever we go
vocabulary
anywhere to
of
do whatever we were
Islam.
doing,
So
my job,
anytime I speak
Yeah.
Farsi,
they'd be like
it sounds like
an
I'm
Asian like
complaining
security
a
guard
lot.
to us.
It's
Out
it
of
gets
nowhere,
to the
these
point
two
where
start
I was
communicating
like,
in
you
Indian.
know,
I'm like, wait,
I can't
relax,
complain in
bro.
English. I'll just sound
Did I miss out on the
like,
Hindi
like
classes in
Farsi,
school? Like, what's
like,
going on here?
you
You know,
know?
it's cool. It's a nice
And it's
fusion
like,
of places.
I feel like when you speak in Farsi, it's like you can use words to like you can just convey a lot more emotion in like another language than you can in English.
Yeah, no.
Oh, English is so flat.
It's so flat. Yeah, I agree.
No,
Bro, swearing in
Oh, no,
Arabic.
yeah, it's white.
Swearing in Arabic.
Yeah.
Swearing in English doesn't count as swearing.
Like,
It doesn't. It's
No,
not
no,
real swearing.
no, like
That's why I
this-
say fuck all the time. This doesn't mean anything.
Yeah.
Yeah.
No, actually, there are some words I've seen people like fucking almost die over some words in Arabic, but like in English, when I hear people swear, I'm just like, wallah, really? Really? Yeah, okay. I'm so offended. Bro, especially when I'm like gaming online North American servers, it's crazy. Where I'm from, bro, I've cried over a gaming session before. I came to North American servers, this guy's like, oh yeah, fuck you, you dick sucker, blah, blah, blah. Dick sucker, that's an insult? Like, okay. Nice, man. Or fucker. Fucker's my favorite one.
Motherfucker.
No, just fucker. I've heard white people stare each other down like, you fucker. What does that mean? What, you have sex? That's the insult? That's all it means? It's an adjective that somebody associates with the act of having fucking reproduction. That is not an insult, man. I do not feel offended. An insult is when you start dissecting someone else's mother's vagina. That's when you're hitting.
No,
the
he's not wrong.
That's when you're talking. What? That's when you're
No,
offended.
some of the swear words that like my aunts have taught me, I'm like shit. Like
Yeah.
it sounds so bad, but if I say it in English, it doesn't mean as like
With great power comes great responsibility.
exactly.
Be careful.
Translate one.
You can't just say
literally.
these words. Sorry.
Translate one of the swear words.
Okay,
just
so one of the
literally.
swear words is I think it's pussy or something like that.
Which
And
means vagina?
it's something with vagina.
Right,
but
because
it's
we say it too.
Yeah.
Yeah.
Kusomak.
But
It's
like,
the most standard Arabic insult. Don't say it
but
to anyone. though.
don't say it. No, you'll get shot.
You
Like,
get stabbed.
don't-
No matter where you are, it doesn't matter. It doesn't matter. Like, I don't care how law-abiding the country is. That's a red line that people are willing to die for.
Yeah.
No, don't laugh, guys. I'm serious.
No, they're stronger though. You could get like go someone enough on it. You know.
Oh yeah, that was one of my
No
favorites. Go suck the sack, بص اخت الساعه اللي طلعت من طيز ابوك. The sisters, the vagina of the sister of the time frame that you came out of your father's ass. So I'm not only insulting your father and his ass and you coming out of it, I'm insulting the very essence of the time frame in which you came out of it. Like, I hate the second you were born in. To me, that is the worst period of human history. The sister's vagina of the time frame of when your dad's father. Yeah, like
in Arabic, there's like Yelan Abuk or something like damn your father.
curse your father.
Yeah, curse your father. But there's also Yelan Tarihat, which means damn your history.
Like your lineage.
And like your history, not as in you, as in like
the family members.
all of you, all the way up to the first.
Oh, like your ancestor, like your whole.
ancestors.
I
and
hate
descendants,
all of you.
Everything.
Oh my God.
I
The
hate
whole lineage.
it also can be understood as I pretty much hate everything you stand for.
Yeah.
Because you stand for your predecessors and I hate all of them, so fuck you. Yeah.
I like this one insult in Farsi. It's like go to hell, like so called the but it directly translates to English means like bury yourself. And it's like it's kind of funny because I'm like, you can't just say bury yourself, but like in Farsi it makes sense. Like it just means go to hell. But like, you know what I mean? Like
Yeah,
if you
yeah.
directly translate, it doesn't make sense.
Yeah, I get what you mean.
I love that.
No, I like when I like to translate strict from English to Arabic to English.
Yeah.
I like to give it very like Shakespearean because I'm not even like being funny. I tend to find that it's easier for people to grasp it just because
the gravity.
because they lost a lot of figurative language. The English speakers, like seriously, there's no like Jamal Lughawi is what we call it, the beauty of language. There's not English speakers don't use that anymore. They try to be as concise as possible, but that just takes away from like history and culture.
Yeah,
like
yeah.
then that language is just
This is
then
why
it's a
when
tool
I-
at that point.
This
It's
is
just a
why
tool.
when I watch soccer or sports, I like Arabic commentators.
Bro, anyone just not the American knows
Yeah,
this one.
just not
Like
the
I
English.
try not to make people feel excluded. Like it's okay, the non-Arab ones are also fine, but strictly North American.
And the English.
Messi,
The English is
Messi gets the ball. Messi, he misses. In Arabic, it's like, yeah, Ronaldo, ergo de Ronaldo, ergo de Ronaldo Sajjad. You know, it's like that. You don't get that in English.
It sounds so much more entertaining.
Yeah, no, I don't like football, so I watch for the commentary, not for the players. I'm serious. I'm really on this one.
Yeah,
I find it
yeah.
super boring. But
understandable.
I've always like been so bored watching sports. I don't know why.
I like playing sports. I don't like watching. 'Cause-
Yeah, participating. So I mean, I'm shit at sports, but
I don't
at
like
least you're
watching
doing
most
something.
sports, but like soccer is the exception for me.
I should have gone food. This combo was really
Yeah,
good.
go get food.
No, I think I'm having way too much fun.
No, we'll talk more when you get back. Let's go.
Come with us, then we can move the conversation with
I
us.
can't leave Nat alone. It's okay. I kind of want to stay today. I know if I leave, I'm gonna buy something, and I don't have to do that.
The last comment.
Yeah,
It was
that's-
just so beautiful. She said the word Kazimi. All three of us looked at her like, "Oh, you're Afghani." Like
Yeah.
that was amazing, especially because she
I-
built it up to be a difficult thing. She
No,
said,
because people
It's
always get it
difficult
wrong.
without the last
people
name.
did.
Yeah.
People, I've seen her do with a whole bunch of people in our class, and not like a single one has gotten it.
On the first time.
To be fair, not most of them.
Yeah, when it's white people, they don't know.
"I don't know anything actually."
Yeah, they don't know. Like it's like they guess. They try to think of it objectively, and then they're completely off.
It's
so
funny though, because also
Like
people
Gary
try
can
and
put, like,
guess
the
in a way
first
that's
name
not
can throw you
offensive.
off.
It's yeah,
Which
it's
is
not
problematic.
That's
Which is
that's
really interesting.
you know what's
because
funny?
it's just
So
like,
my first
why-
name,
what's wrong with
it's
guessing?
actually not
Because
Getty,
you have
it's
these- all these
Getty.
other like
That's how you say it
negative-
in Farsi.
Yes.
But I told
yes.
Yes.
no one ever
People
calls that
are-
unless
That's
it's my
what I'm
parents
saying.
or my older
There's
sisters.
straight
No
up
one
like
else
one
calls that.
person in
Sure.
our class.
Like only in
They,
Farsi.
she played that game with them, and like the first thing they mentioned after she told them like she was Afghan, she's like, "Oh, Taliban." Just like you
I
know,
was
like that's not the first thing you say to somebody.
Rest-
Like what?
No, like
Excuse
the
me?
issue is that like
Yeah.
to show you like the difference, like I totally forgot about that. Like you just reminded me that there's a Taliban in Afghan. I don't think about that stuff. Like to me, that's not like
The first thing that comes to
Yeah,
your
but that
mind.
like okay, dude,
But
like
it comes
that's the
into
first
my
thing they
mind is that,
said.
like, I don't
It's
want to go
like,
there.
It's a beautiful country. Like I went there when I was a kid. I just can't go back.
it's vibes, bro. You know they have the
Yeah,
most
no,
beautiful
like-
eyes on earth come from Afghan, bro. You ever seen those green eyes those motherfuckers have?
Yeah.
Bro, they're
It's
crazy.
crazy. Like, my
no, like
cousin
some of
had-
the greenest eyes on earth are from Afghanistan.
My dad went there like
I've never
a
seen
year or
person
two
in my
ago.
life.
Yeah.
He went there like 2 months before everything
Yeah,
went.
no.
I'm
Oh,
from
yeah,
Kilo
what
very colored eyes,
part?
which
Kabul.
is the opposite of what people
So he
think.
was in Kabul,
People think the Middle
and, like,
East,
feels
like,
like them.
we are all just
really
like
wanna
what
go
you
back.
expect a sand
And
turban
then-
wearing person to be.
Yeah,
Like,
like
where I'm
I
from,
felt so bad 'cause,
every
like,
I think I have more friends in the Middle East who have colored eyes than here,
but-
and
Literally,
they're all Arabic.
The
No
only-
one's white. I don't have a single white friend back home.
the only people I know with colored eyes had either blue eyes or gray eyes.
Yeah.
That's it because I grew up in like a really white Christian area.
Mhm.
But
Where?
Yeah.
it's all retired white people.
Oh,
The old people.
Lovely, lovely.
They're all like everybody's either Dutch Catholic or German Catholic.
Yeah.
Or just Christian, like everybody.
Mm.
They're all like 70.
Yeah. So like it was so funny because it was like literally I was in high school when somebody said, "Oh yeah, like redheads and blondes, they're actually a very, very small percentage of the entire population
Yeah.
of Earth," which when I was a kid I just didn't know because everyone around me was blonde.
Yeah. I get what you're
So,
saying, yeah. So it was a weird statistic.
Yeah.
It is true though, because usually lighter features, they're usually weaker. Not just like between the DNA, just literally even like environmentally. For example, my eyes, they're very prone to being burnt off by the sun completely more than everyone else, right? Just because I don't have the same amount. Even my skin, for example, I don't have the same amount of melanin, so when I burn, I don't get tanned. I get skin cancer. And that's not a joke. My dad did get skin cancer. He didn't die. It's fine. Like he got over it in like a week. It's fine. But like he did though. He developed skin cancer from just being the color he is at all.
You gotta be careful.
Hair's weaker, falls off quickly. Yeah, so these traits, like, that's why 2.5%. These traits are usually just like we're all bound to end up not looking like me in like 20,000 years. Like, that's fine. Enjoy me while you can. You know what I mean? Like, yeah. Very weird. The other day, somebody called me a white boy. I got so. Like, by the way, for the record, I sound very like anti-white right now. That's not why. It's just been a very rough 2 days for me.
Oh yeah.
Like culturally, so I'm not anti-white. All my friends are white, but like
People always use like, "Oh, you're so white" as like a direct insult to having a lack of culture, though. So
yeah, like
that's why
it
it's,
feels
an
like,
insult.
especially because like even amongst Arabs, like I know I don't want to sound like egotistical, but I'll just give you a fact. Like even amongst I'm more culturally like carrying the culture than even like other Arabs. So when I feel like people look at me and just strip it all away just because of the way I look, I'm just like,
Honestly,
if only you know
fact
the
is,
truth. If only you
I'm
knew
way
the
more
truth.
Arab here than like.
Then
when I
back
go
home,
back.
yeah, it's also true because when we're diaspora, that's the word for it. When you move away from your culture,
My Arabness actually comes out.
yeah, like if anything, my not just that, even like my language skills have improved. I write and read better now.
Yeah.
Just because
It's
I
weird.
feel like it's necessary to, because I don't want to end up like no
I
offense to
listen to
anyone. but-
Arabic music. Of my own
Yeah,
accord.
like literally now, like in Dubai, it would be a meme if you listen to Arabic music. What the fuck is wrong with you? Go listen to Little Baby. But now when I'm here, like, look, I just opened Spotify and it's an Arabic song. The song, I cry to this shit every day, bro. Like, serious. It's called Mayyil Al Baladi. Bro,
I'll
this
look
shit's
it up.
beautiful, bro.
I'll look
It's
it up.
beautiful.
My second most played artist this year on Spotify
was
Fairuz.
Feroz. Me too. If you look at my Spotify
I
rap,
saw.
so Aluni Nas number
Everybody-
2 and number 3, and
everybody-
An was number 2, and then his Rebellion song. Not free Palestine. Anyways,
Go get your food.
I'm starving.
Go get
Go get
food.
your
I'm
food.
Go
fucking
eat.
hungry. Let's go.
Go eat. Get food.
Okay, stay here. Yeah, I wanted to go on a walk, but now I'm just like,
It's freezing. It's cold in here. I don't want to
it
go
is
out.
kind of
It
cold
is
here.
good.
I brought my sweater.
And I brought a half-eaten burger. So I'm gonna eat that. That's my lunch. I don't know if it's still warm. It's not.
Probably not. Let's be really. It was good though. Where'd you get it?
I went to dinner last night with my parents. So I got it from there.
Where'd
Oh
you
wait.
go? Wait, where'd you go? Oh, it's very eating.
So we went to this place called Proof Kitchen. It was so cute. And it's like I really liked it there. And the funny thing is that it's all math themed. So like it's called Proof Kitchen because like proofs.
Oh,
And then like their menu, like everything was named after like some sort of solving thing. Like the appetizers were called the origin, and then the theory of the mixing theory, and then the other page. I can't remember the rest, but I remember the dessert menu was called the final solution. It was just so cute. Yeah, it was so adorable. Like you guys should definitely check it out if you're math people.
and then when next time I have money to actually go out and eat food. When we went out for dinner that other day, that cleaned me out. I'm just like, okay, I'm not eating for a week.
I wanted to go there at first, but then it was busy. I'm like, it's a Thursday night.
Yeah.
Weird.
Some places, like, since COVID, reservation stuff has been
They
like,
just left.
Yeah, we were having a random conversation about culture.
Wait, who just left? Like Sandra and
Oh,
they
okay.
just left.
Where'd they go?
I don't
not a
know.
clue.
Probably strong.
That looks good.
Yeah, okay. I don't know which one's which though. They didn't. I'm pretty sure they wrap them in different colors.
Just like open it up.
You don't know.
Yeah. There's different sauces inside. So
What did
it's a
you
bit
get?
hard to tell. I got Arabicana, which should have like pink pickles.
Pink pickles? That
There
sounds
has
fun.
pink pickles on them.
Does it
Don't
have
you
pink
mean like
pickles?
pickled turnip?
Okay, no, I haven't seen it.
Or like
I don't know. Pink pickles sounds cool though.
It was nice if you had written it on.
Yeah.
And you like
That's hard to tell.
encased it. Stuff. This is why I suggested Lizzie's.
No, but okay, I think this one's yours.
Is it?
Yeah, I think it's yours.
I don't see any
Pink pickles.
here. It's in there. No idea.
Gotta dissect it, guys.
I think this one is
Okay.
just because of the sauce.
Oh,
Alright,
it's my
if
stuff.
it's-
Oh, no,
It's
it's just like,
still
what's the same time as the
No.
fry pan?
Lizzie's,
You
you
shouldn't
just
have
don't
it.
get a large half and half. No. No bacon.
I mean, you didn't want to get You could also get a half and half, but we didn't get that, so. Try that.
What are you guys doing after this? You gonna study more, or you need to go home?
Oh, no plans so far. Probably need to study more, to be honest.
Me too. I have so much I need to do, but I keep telling myself like, oh no, it's fine. I can just go to the workshop and then I'll be fine. But like, I have so much extra stuff to do.
Like honestly, that's how I be. Like, I'm trying to do this just so I can lock in some number of hours of studying for myself. So like, I know
Yeah.
that during these hours, I'm gonna study.
Teaching's a pretty good way to learn the material.
Because like then you're explaining it to yourself as well.
I believe it's so funny. My dad had teach history one time. He's not a history teacher. He's a cooking teacher, but it was hilarious. He learned like half that shit like when he was teaching.
Oh my god.
Yeah.
One time during co-op, so my co-op was like a camp counselor, but it was like with coding. And I had to teach a group how to do web design. And I've never done web design before. And like I learned so much. It was so much fun because like it was funny because the other counselors who were doing something else, they knew how to do like HTML and CSS, but I didn't. So I'd always, when I'm explaining stuff, I'm like, wait, is that right? They'd be like, no, it's this. I'm like, oh, okay. But I learned it, so it's good. But it was really fun. Yeah. I basically got paid to play robots with kids. It was great.
Yeah. Sounds fun. I got paid to be on ladders. So
What was your
On
goal?
ladders.
my co-op was basically installing like Wi-Fi hardware, so like ACs and stuff,
Oh, okay.
and then like some security stuff. But nothing was actually really technical. It was more construction and like contracting stuff.
That's cool.
It was okay for like a week, and then I'm just like, I don't want to be here anymore. I don't know how mounting a TV is gonna help me in the future.
I
You
mean,
can really milk it. You can really milk it. Like you could be like, oh, I was like hands-on.
I mean, that job got me the job I have now at school, but at the same
what are you doing
time,
next term?
IT.
Nice.
So like, I was like on the other side of IT.
And now
Where
you're doing IT.
maybe I'm still a little confused on that. I think I'm supposed to be helping them collect data and improving Wi-Fi, but then they also came out with the new EduRoam thing as well. And also, okay, so I'm repeating, right? One of the professors for 111, when I first took it, was absolute shit.
Oh
Like-
yeah, everyone has horror stories about him.
Yeah, I'm trying to remember his name.
It's some, I don't know, I forgot what his name was, but he's evil.
Yeah, he wasn't good. So like the professor you guys had for 111 this year,
You did master.
yeah, I'm an
So
after.
long.
It was not
I've heard from the upper years.
good. Yeah, it was not good. So I had NASA. Basically, I failed his exam, and he told me to drop out of the program. Is like the short of it. But other than that, some of the emails have like come from him, and I'm just like, shit, is this guy in the IT department? Because I do not want to be
Yeah.
anywhere close to him. Like his entire personality was, I'm an MIT reject. I went to Carnegie Mellon. Like that's his entire personality. That's all he talked about during his lecture. It was so bad.
Yeah, my email.
I do not want to go anywhere near that person. Luckily, they're like two co-op hired up, so hopefully,
That's good though. Then you actually get to like talk to people,
yeah.
you know, and like make friends.
I hope so. I'm not
Cause like
very
I'm remote again, so I'm just
Oh,
like sitting
really?
at my desk at home, just like clicking buttons, going on my phone. I'm just like, you know what? Like I'm getting paid, but like I'm also just clicking buttons and going on my phone.
Wait, what is it?
Just like I'm doing data engineering this time.
Okay, that sounds fun.
I know, but last time I was clicking buttons because that's QA.
though. Wait, so does it at least pay like really decent?
Yes, it does.
Okay.
Which is why I'm not complaining. But it's
Yeah.
just like, you know what?
Yeah.
My coworker was like, she was like, I knew more than her, and I was like, wow, because she came like a week before me.
Oh.
So it's like she was trying to teach me stuff, and she couldn't do it.
Wait, they put someone who's only there for a week in charge of training you?
Not yeah, basically for like something. So I was like,
Okay.
come on, guys. Like there was
Yeah.
the supervisor, but like she was busy with other stuff. So it was mostly me and this like person who was worked there for like a week more than me, and we're just trying to figure shit out together. It was kind of fun though.
I mean, that's pretty good. There's literally one person I was working.
Loading my software onto different phones.
No, it was just like setting up the VM, setting up my account. Like, she didn't know what was going on. She was like there for a week before me. And then we were trying to like log into the VMs and you have to use like 4 different passwords. I'm like, where did these passwords come from? Like that kind of stuff. She was just like, I need to check my notes. I'm like, yeah, go check your notes. It was fun though. I'll probably see her again since I'm working in the same company.
Oh, wait, what company?
Curanos, like a finance.
Oh, okay. Yeah.
Seems pretty fun.
Do you guys have co-op flush whatever, maybe?
Do you have yours confirmed? Okay.
What are you,
I don't
Jesse?
have a confirmed one either, but I have conditional offers. Like, as in, I have to go back to Beijing and then do the interview. So that would be like
Oh, that seems
mid-January. I'll do actual interview. So it's me like.
Yeah, that seems really stressful.
Yeah, one of them is with a research assistantship with a scholar who does like lithium-ion batteries and research.
That's cool.
That's actually really cool. Oh, sorry, Daddy.
Yeah,
Yeah.
it's really interesting. And then
Does anyone want a cookie?
oh, that's amazing.
Do you want a cookie? Anyone?
No, it's okay. I'm eating some other
It's okay, thank you though.
Thank you.
You make these?
Huh?
You make these?
No. I bought them from Walmart. It's just because I keep getting the cookies from fucking Tim Hortons and they're just not worth it. They cost me like $1.30. I'm like, these things used to be $1. They used to be 99 cents.
Yeah, they're not 99, 95 even.
No, like
The
now
classic
it's-
donuts, 95 cents. What was it? Now it's like 150. I'm like, come on, guys.
Some of those
Come on.
donuts are $3, and I'm just like, why the fuck would they be $3?
Yeah, like there's stupid pastries that they just came out with the cross. No, those are $3. What the fuck? I
Yeah,
can go
those
to
are
the
not
convenience
worth
store and
$3.
get it for cheaper. That's so stupid.
It's just that you have to go to the
Yeah, you have to go to the convenience store.
That's the problem.
Literally, like, food's gone up so much, I'm crying.
Yeah, especially
I
here.
guess you have to eat food. It's not like you can like forego foods.
I've noticed like in Waterloo, especially like food is so much more expensive for some reason. Like, yeah, like in
I don't
Toronto,
find so.
it's like in Toronto, it's not that expensive. Like here, I found like eggs that are $4 or $5, and then in Toronto, it's like $2.
Literally, the cheap ones that are supposed to be $2 for $4
That's
at
true.
Value Mart.
Eggs,
Yeah,
eggs,
Which Value
yeah.
Mart is like more expensive in general, but
it's just kinda
It depends though. Like sometimes you get good stuff there. Like it depends if you find the sale section or not. Is
yeah.
what I do. Or like the meat that's just about to expire, you just put it in your freezer for like 4 months.
stupid. Yeah.
Oh yeah.
Yeah,
My
yeah.
meeting is gonna take a while. Might take until like 55 or something.
Sorry.
It might take a long time for me to finish eating.
It's fine. They're still gone.
They're
They haven't
still
even-
gone.
They haven't even gone back.
Yeah, and I'm sure they're also gonna want to eat. So
Oh,
like,
yeah.
you'll be fine.
And if we go a little overtime, I don't know how you guys feel about it, but I have no plans, so.
I have no plans.
I'm a loser.
I never have any plans, so I'm not gonna lie.
Guys, what should I draw? I gotta draw.
Oh. Getty, look at what I did that with my right hand.
You did all this with your right hand?
Yeah.
What?
Uh-huh.
I could not do that with my left. Anyway, let me.
Well, I can't. I have trouble drawing with chalk with my left hand because I just erase.
Oh,
it.
you. Yeah, right.
I have trouble like going like this though.
So we're like most ancient Arabic people just
Probably
like
could. I was just like
left-handed so that they decide to back from the other side.
I take requests. What should I draw?
No, I got the left and right side.
a butterfly with
A butterfly with
draw a fuzzy butterfly.
a fuzzy butterfly.
Oh.
It's like a moth.
One. If you reach the intersection.
No, fuzzy butterfly.
So turn left, go to the door.
I don't like moths.
Yeah. Right. I don't know how to draw. Okay, guys, I only know how to draw people. So give me those kinds of requests.
People?
Yeah.
Draw Jessie.
Jesse?
No.
Okay. Okay, wait. Let me just finish my.
Is this still recording? Oh,
It's recording?
is it? It says live.
Oh, that's
Yeah, it's
funny.
still streaming.
They're gonna
Oscar,
see
where
my
are
artistic
you?
skills. We're over here. Okay.
Oh, okay.
It's a fluffy butterfly. Okay. So you said Jesse?
Yeah. Are there water fountains here?
Yes. I can so turn left. Go
The water fountains
straight.
suck. But they exist.
I can do that.
By the way, have you are you still looking for a co-op or like have you confirmed one? Oh. Oh.
No, it's not.
Interesting.
Okay, until he's in the
They're chilling on the floor. Are you serious?
Okay, this is kind of messy.
This water tastes weird.
It's okay.
Oh.
I don't want to draw glasses, so I just did circles.
I think that's good.
I wish I had colors. That would make this. Oh,
There's no colored ones.
that looks so much cuter.
Oh my god, this gives me reminiscence of like elementary school.
Yeah.
So like in China we have like a blackboard at the front of the class and a blackboard at the back of the class. At the back we're supposed to like every month we're supposed to have like a new kind of like slogan on there.
Oh.
It's like your whole class is supposed to like design it and then someone's supposed to like draw it each month.
Uh-huh.
So they will also like have a ranking of like which class did the best and stuff like that.
That's cute.
So
Yeah.
people use like colored chalks. Like sometimes people draw like literal characters on there. It's like
Aw.
whoa.
That's so cute.
This reminds me of like
It's very oversimplification.
nah, it's good. If you go too detailed on the blackboard, no one can actually recognize what it is.
Yeah, it gets kind of difficult to draw on the phone. I'm gonna throw my backpack here. And my jacket there as well.
Good idea.
Just throw shit here. I thought someone was sitting here, that's what I was like, too scared of myself.
Oh yeah.
But, just use over there.
Actually, no, this can all just stay here. There's literally some minor like this is here. And they just like.
Oh yeah, make it open like that side.
Yeah, 'cause, like, this one's like that.
Close the disk tray on the computer. In Python.
Do you want to see something?
Yeah.
I get
okay,
really
so
good at
close?
drawing when I
Oh,
get
no.
stressed.
Oh, that.
Simply because I
that's
just
the
don't
one
want to
that
study.
Sliced my wrist open.
Yeah.
With a box cutter.
Oh, that's
It was,
so.
I was.
Oh,
this
so
one I worked at
good.
Neutrals. Grocery store. I was cutting open a box
Yes.
and.
The colors go well, like really well together.
Yeah, I know. It's because
Yeah, that
okay,
was,
so basically I was walking home
see,
from class,
You wrote that.
and right outside the QC I saw a girl
Basically,
walking. This is the
put it in
position
the
she was
loop.
walking in, and she had like a red hair and a bandana and a brown jacket and green pants and
So
black
it was
boots,
like.
and it looked
open
so
and
cute. So I'm like,
close
okay, I
and,
like to draw.
random
That
intervals.
is cool.
I love being inspired by everything.
You did the hair.
Idea
really
of being
well.
someone
I'm
sitting in
fun
class
with
and the disk tray just starts opening.
This was I kind of like.
I don't know, because we weren't in the
You
class.
should make it like a webtoon. That'd be so cute.
I would love to make like
Yeah.
a cartoon or something like that, but I just don't have time for something
Yeah.
or any ideas. Like I do, but not.
Geography class, like in elementary school. and then like someone just like decided to like the
Hazel
had like
probably
a server
because Anika's leaving on Sunday
that
now.
has like a lot of requirements, and the thing that you're supposed to know is like how to use a
Damn
Word
it.
document.
I thought these were the soft cookies.
Make a document where the
I've been
page is
scammed.
like, has some text on it. Stupid. Ultra stupid. And someone was like, this is so stupid. And like, it goes onto the server, like deletes all of the file, wipes the entire drive. And then we didn't have IT class for like 3 weeks because they didn't have the material to teach us.
For the lab,
Oh, yeah.
She said there's no
so
lab
we were
report. You have to
using
make one
VMs
yourself.
for one of our classes.
No, I
right?
read it.
Make what?
That's where we had all of our.
For the lab report.
Projects.
You can make a lab report yourself. Does it
And I
even
was
say what you
bored.
have included?
I was just
No.
closing.
I just have to follow the
tabs
format
on
view.
the
That's
task
easy.
again.
Oh, wow. That does not go well.
Yeah, I crashed the game.
Definitely.
Thankfully, it was just the VM and not the actual computer.
Dumbass. No, like dumbass.
I was wanting to see what happens. Like, what happens when we end this task? What happens when we end this task? But, nah, all good.
Are you still into computers or like?
Man, but it's hard to find jobs. Because
You don't wash my water bottle.
my
Did
grades
I
are
just-
that. And so after that, like,
I'll just go.
I'm also like,
Chilling, vibing.
something like that. Yeah.
Shit. Thank you. Oh my god.
It was about to roll.
Yeah, the Rick and roll. We can put on some
Well, ooh, I did that in my 111 project. I incorporated a Rickroll.
Nice.
Yeah,
What did you do?
it was okay. So I found a way in Python to open a browser extension.
But what game were you doing?
Oh, I think I did blackjack or something. I just coded my own blackjack game
Yeah.
using the Tkinter GUI, and I found a way to open like a web browser with a click of a button. And so I put like I put like a little help button in the corner.
Oh, it's there. Here's one of the Oscars.
You really should just keep that zipped up.
I should, but
Yeah, it was a pretty sweet game. In the
Rickroll
corner,
help button.
there was a little help button, and except when you clicked it, it opened up the
YouTube.
YouTube the music video of Rick Astley. So
Nice. I'm glad no one.
I showed it to her, and she thought it was pretty funny. So I think
Oh yeah, there's a schedule, but they don't start until next week.
then in high school, I was just showing her. I wrote a program to open and close the disk tray in the
But it already
computer.
happened. It was from like 9 to 11:30. That was just. I think we can get through the rest of this. We can get through it. It's starting to become a little bit slow for me.
Oh, this water tastes like ass. Oh my god.
How do you know what ass tastes like?
Shut up.
I am finding what's on the board a little bit dreadful, so I
Really? I think
Is
I
that
think-
started?
which part do you find dreadful?
No, it's just like having to go through all of them.
Oh, fair enough. I think Fourier was gonna take the bulk of it though, because it's
That's
like
fair.
you had to go through everything. Like
Yeah.
Laplace is just like look at the table basically for like
Mhm.
50% of the questions, and
I
then
just want to
series
actually
solution.
ask to like solve this system or whatever using Laplace or something.
Oh yeah, the last question on the assignment, I gave up. I'm just like, I'm not doing this.
I said
Oh my
use
God, it's
simple math. I
awful.
was like fuck no.
It was awful.
Absolutely not.
Yeah, to invert it, that was I don't think you'll get it.
No, he won't. He would have to make the exam 5 hours long and only have that.
Okay, the thing is, though, is
Hello,
he was
welcome
like,
back.
oh, you should be able to do this throughout the day.
Yay.
Oh,
Nice.
No, we got bear hungry with that conversation we were having earlier.
What do you guys each get? Biryani
This
for
all got the same exact meal.
Really?
That was
You
just
should
fancy,
really
and you grab a
try-
piece of bread with it.
You should really try the poutine with beef curry.
Yeah.
Nahari?
Mm-hmm.
San is against it.
No.
San is
I
against
tried
that.
it.
That specific item, that's one item you do it.
Yeah, walking over there, son was like, I had a bad experience with onions.
Dang.
What
okay.
happened was I was studying and I was hungry, so I go there. It was crowded, so like I had to wait for 20 minutes, right? So
Yeah, that's
that was
what I
one
heard.
thing, and then they forget to give me forks, and I'm already back at the engineering building.
Oh.
So it's like I
So
have this
basically what they
greasy
did to us
bag
today.
I have this greasy box of fries, and it's like dripping down, and I'm trying to find just forks anywhere. I look in the bakery that they have, but it's closed. So to go back into the plaza, come back, and by that time the fries are cold. It's like soggy, greasy.
Oh,
So
okay.
like I just didn't like it.
Okay.
So it wasn't the food's fault. It was the food service's fault. They didn't give you a fork.
Taste wise too, it wasn't like
Yeah, I mean, you
think
had it cold and
shawarma,
soggy.
you need to have it. No,
I feel
sorry, like
the
poutine, you need to have it fresh.
Either
So.
the sauce and the toppings are really good, or the fries are really good. And there's no like.
There's never too good.
Yeah.
Too good parts.
And if they are, they're just stupid.
Yeah, so
For what it
I
is.
would usually ask them to put the like curry on the side, so the fries don't get soggy as much. But understandable. That sounds like a horror.
Bro, even the
experience.
thing they gave us to make it less spicy, in and of itself is spicy.
Bruh.
That's some commitment right there.
Did they specifically say that? Hey, it's for making your food less spicy.
No, that's the whole idea. It's made out of yogurt and mint and cilantro, so it's supposed to give like a
yeah,
Yeah.
no, that.
You're right, though.
Cooling feeling.
yeah.
Yeah, I'm gonna need to get some water too.
No, it's okay. Thank you though.
You're getting an entire other building to refill the water bottle. Like,
Yeah, because usually the water's just like ask like, okay, never mind. I don't want it refilled then.
yeah, it doesn't have
Y'all ever had V1 poutine?
No. Didn't live in V1.
Guys, it was fucking amazing, man.
Y'all ever had pennies?
What is it?
Pennies. Right, I checked with you.
Wait,
Yeah,
let me
that's
restart it.
Oh, yeah.
Yeah, you saw the video?
No, but like, that's
Oh,
what we did.
yeah. What do you
I
like
couldn't
filmed?
tell that. I couldn't tell.
I think I was somewhere there putting it up,
Oh, yeah.
Someone else. Oh,
and then we had to take it down because we used the rake. Hello.
What'd you get?
It's everyone, not gonna lie.
We all got biryani.
Oh, biryani slaps.
He has a diet.
It's good stuff, but also I should have gotten water with it because my mouth is dying.
Oh.
Yeah.
I went to
Where did you
fucking-
go?
I had to go to RCH. Anyways, that hallway right there, it's creepy as shit. And I was just thinking about like, oh, this place like it's so scary. And I look to my right, and it looks like blood is oozing from the wall. But it's probably just glue. It's probably just glue. It's not blood. But it just scared
Probably.
me, and I was like,
Probably.
walking, and I'm like,
Probably.
yeah, I just scare myself too often. But it was really scary. Like RCH is definitely like it's ghost town there.
There's no.
It's scary. But as we know, like there's backup stuff for us to move to.
Yeah,
Yeah,
so we want to
I
stay in
did
the
not
jail
know that
cell.
they
In a jail cell, yeah.
biryani this large.
But
I mean, it works.
I mean, even this room is really boring.
But I like this one better than our.
They on Mondays.
Than the other place.
Mondays and
I
Fridays.
guess
they
it's
have
bigger
like
here.
It's bigger.
biryani for like less
The
than
chairs are
$2, and it has like it has like actual pieces of large chicken inside.
Mm.
And it's like a massive portion. You can also ask for like a spicy sauce with it. So
Food's so expensive in Canada.
It is.
And it's gone up in the last
Waterloo is.
year, couple years as well, which
Because
really
of the
sucks.
pandemic.
Why inflation?
Yeah, because billionaires just need to get richer, right?
They were already rich. They were already getting richer because of pandemic. And now they
Where's the water, by the
And then
way?
they increase food prices.
it's like
housing prices.
and blame it on
and-
inflation.
yeah.
We should have that. We should
And
try
then
it.
Russia invaded Ukraine and made grain shortage happen.
Isn't the fountain back again?
Yeah.
So even more expensive.
It
I
tastes
remember
like
there was that week I couldn't
tastes
find
like-
hot Cheetos
No.
anywhere.
Yeah.
I don't eat them anymore.
That's a prime example of food shortage.
Yeah, I'm everywhere I went for a whole month actually. Everywhere I went, I could not find hot Cheetos. It was insane. Like not even Walmart. You think Walmart would have it, or like anywhere else, I just could not find it. It's
crazy.
Literally, the Lay's bags of chips are like $5.
No, yeah.
each.
Like, what
So
is
just
that?
like
Yeah.
for that, just buy the
There's no
potatoes
doubt
and make
what's-
chips yourself, and they'll be better anyway.
Yeah.
I went with my dad to the supermarket the other day. He's like, "Why is shit so expensive here?" And I had to remind him that's without tax. Like,
Yeah, it's not even like
Okay, that's something that pisses me off. Why does Canada do that? Why can't
I don't
they
know.
just
Wait till
Because-
like guess the price when you walk out the
Because
cashier.
in the UK,
They just like
they include the price.
It's because some people. It's a bullshit reason, right? But
So that it looks less expensive.
no, it's not even that. It's the veterans. They don't pay tax.
Oh.
But they're also only like 2% of the population or something.
Yeah, you could
So I feel like
They
it
get
takes.
like tax returns or something.
Better.
yeah.
Bro,
Like, oh
I'm joining the army. Fuck that.
He doesn't want to pay taxes no more.
And like very
You know what money
specific, like
that's
boutique stores sometimes have that
Well,
where
the
it's
big
just like
scam
this is
is
with
paying taxes on secondhand stuff.
But
Because you buy it
That's
once, you
like
pay
the
tax
store
on it,
itself
then you
has
gotta
to
pay
decide
tax
to
on
do
it.
that.
Where are you paying tax for? Like value of village, for example.
Yeah, or like if I buy a used car,
Oh,
you buy the car new, you pay tax on it. You buy it used, you pay on it
No, it
again.
was 2 people in a room.
Right.
Yeah.
It's meant for
That seems like a bit of a scam to me.
So
Oh,
it's
I
a
feel like
lot more
everything's a scam
hassles
though.
than we
Like
did
even
80
things that
to
aren't
70%.
scams, some are
So it was
scams.
it's because we build our societies based off of profit incentive. So everything a government does, it has to generate income. Otherwise, it doesn't know how to function otherwise.
Or like the amount of companies that spend money on furniture just because they have to meet a quota, it kills me.
Slightly
Like,
upscale
yes,
steak
so
places.
companies have a certain,
But
depending
the
on what
one
company
here,
and where they're getting the
like,
money from,
was
usually they have very
had,
specific budgets
like,
for different
really
things.
loud
And so what happens is if
No
they have a
atmosphere,
very specific furniture
bad
budget,
lighting.
well, they want to get that funding
Yeah.
again
Okay,
the next
that's
year, which they won't get if they don't spend it. So then they replace
That's
things
like-
that don't need to be replaced
like you go
because they
over
want
and
to
then-
continuously get that money. Why? I have no clue because they can only spend it on furniture.
No.
And I
Yeah.
guess that they're thinking, oh, well, when we
When we
actually
actually need it.
then they won't get it. So then they just replace like things that are only like 3 years old or like TVs. Warranties are usually up.
I think
Some of them are up after
it's
3
supposed to
years.
be, like, way better.
They just replace the TV. They don't. And then they chuck the old ones, but they just replace them because well the warranty's up.
Yeah.
And then the
Like,
same
I
thing
just think that
happens
out
with
there
like
just isn't
spending money on
well.
useless shit like the
But, like,
courthouse in
they cut
Kitchener.
price
Other than
according
being
to, like,
kind of
regular price.
Mhm.
So it's
there's a
not
lot
like-
of conflicts of interest there, but other than that, they
No, because
spend
the
like
price
money
is
on
low.
those like you know those
Oh,
fancy
you can-
rocks.
No, but they're
They're
like
about this
match
big
regular
and
price.
they're like
Yeah.
flat and then you can like sit on them and shit.
They think that
They have
people
like 20 of
think
those on
that
the roof
sushi could cost this-
for no
cost this
reason.
much,
Sit on.
Even though
No,
their quality
like
is
people
bad.
are only the maintenance
They still
people are even
charge
allowed on the
like-
roof.
Yeah, they don't have
So they
access
just
to it.
have them like on the roof
So
for
I'm
aesthetic
learning
purposes and
to
they're
never
like
have
500 to
outside
$1,000
city
each.
centers, unless it's
And
local.
that's not a huge chunk considering the building's like $1 billion or
But
something.
like,
But
Like,
it's
I once
useless
went to,
spending. And same
so
with
I
like
lived in
the
Beijing, like,
judges' quarters.
metropolitan.
They have this office
I
like
once went
half the size
to,
of this room
in university
with just one
campus that was,
desk and they
like,
get their own
about
shower
half
and
an hour
bathroom and
drive
shit
from
in there. Like
and
it's ridiculous
I
because half of
tried
them aren't
to
even
have
there. They were like
something at
still
the
working
restaurant
from
nearby.
home, aka
it
their
was, like,
cottages.
so sushi with mango. And the
Because
mango was spoiled.
you know, pandemic
Oh,
allowed
and
them
it
to
was
work from home,
really
and then
expensive.
all
Like,
the
for
$1 billion
what it was,
buildings are empty.
They
yeah.
did not know how to
And
sushi.
it's just crazy
And also, like,
because so many companies do that,
like,
and that's a
place
government
support
building, and
music.
they've done that. So
I
like
was like, oh,
the
like,
amount of just
and
unnecessary
after we complained
spending
about like the
is
mango
ridiculous.
being spoiled,
They
they
bet
tried to
you
get
guys
no
should
spoiled the
be,
same
like,
spoiled mango, and then they didn't even like deduce the part
They are. So yeah, it's
This
just
is what happens when you're a capitalist. I swear.
yeah. I mean, same thing. The same
It's
things
bad
happen with
experience.
schools
Like, never
sometimes too.
going to
If they have to replace
outside
like
the
computers
city
and stuff,
food.
they'll do that. The same thing throughout the old ones because it's not even like they're reselling the old stuff. They literally throw it out.
Just make it
Did you
a-
try
So like it's yeah.
Dumpster diving.
Okay,
What was
so last time I was in Montreal, I was in Montreal.
I mean,
Yeah.
some
This time I was
companies
in
do like resell it. Cause like
Um,
my
and
parents
so
work at a company
I
where
did
like they
email.
can buy back them for like
There was a
really
place
cheap,
where,
like
like,
old
you
computers
would
and old things.
finish class
Oh, that is a good
So that's like
idea.
nice.
And there would
Like
be
it
no
is
old
mostly just
computers.
computers because like that's where I got my computer from, my old computer from.
Yeah,
Super
that's
small
good.
town.
So
And I
like
wasn't even in
yeah.
downtown.
I wish more
Vail.
companies did
I
that
was
though,
in
because
the West Island.
I feel like
which
it
is
should
like
be
half an hour
I
drive.
think, but they
practice
do,
and
but they
not-
both work at like smaller companies, so
So
just
not-
like they're friends with like the boss and stuff, like that
Oh,
kind of
yeah,
thing. So like it is. I think it's not a thing for bigger companies.
I feel like it should be like a forced standard though.
Yeah, it should.
Because like people keep complaining about waste and stuff, but they don't do anything to actually like remedy that. They just say, oh, now the consumer has to pay a recycle
Sure.
tax or whatever.
That's like reason.
Yeah.
They're still perfectly
Everything
usable
is
half the time. It's just like
pizza though.
like
Like a calzone.
maybe if you're like a hardcore programmer or something, like you need the best.
Pasta is deconstructed.
Well, like most
It
people
is.
don't.
It is.
Yeah, like you can still use
It's
it.
like carbs,
That's fine.
tomato sauce, and then
Yeah.
cheese. Yeah.
If you want to argue for that, like I
I
don't
don't
think
know.
anything is
It's just
not
like one of those things where I'm just like, I am not
even a sandwich.
very like educated on most of like
There you
how
go.
companies work
I
and
mean,
stuff.
like,
But if like
I don't like
even I'm
tomatoes,
being
raw
like
tomatoes on my sandwich.
there seems to be a problem
Yeah.
there, then
Like,
that's
maybe there's
big
a problem.
because I'm just like I'm oblivious about most things. but-
Yeah, same. No, it's like if I think there's a problem, there's definitely a problem. Because I never have concerns.
Doesn't have cheese.
Unlike me.
Yeah, you have a lot of concerns, unfortunately. Or
Always
fortunately.
have
I don't
Different
know.
enough because it's
What's
like
your most
fried.
recent concern?
It's like cornbread.
My most recent concern is I'm dying of spice.
Okay, but pasta's also different.
Yo,
enough
Sam.
that it's
Did you get like extra spicy or is this
No.
like the basic?
Pasta's
basic.
also
Oh my
different.
What kind of spice is it? Like jalapenos or what's in it?
Okay, but like
Stuff.
Like you just don't
What
know.
kind of spice?
it
Spice?
has the same flavor.
All
It's
of
like
it.
soup. It's like Kashmiri chili powder. Like
Oh.
it's like
Oh.
it's like
Someone does-
like
Yeah,
maybe that's
like
the,
Pakistani biryani.
It's
How you call-
it's a different level of
that's what
spice.
you call pizza.
You can't compare it to just like jalapenos and things. 'cause those
Yeah,
are-
no, it's definitely.
I actually don't like jalapeno spicy. I don't like the
Take a
taste of
spoonful.
jalapenos.
Take a spoonful and you understand.
I'm gonna say
Yeah?
that the tomato.
Can I also try some?
Yeah, sure.
Do you know those like little black things?
Peppercorns? Or-
Black peppercorn.
Peppercorns. I hate those. I hate when they put it in the biryani. It tastes so bad. You just bite down on one peppercorn and then you die.
You know what's
It's okay.
worse? Biting into
But imagine
fuck-
that every bite is that spicy.
biting into cardamom, bro. That shit's a war crime. Biting into that? No. That's literally like I'd rather die.
Wait, I want to try some.
Pretty good, pretty good. Yeah, go for it.
I'm thinking the grapes again. And now we have the.
It's okay when you have
No,
one
make sure you
spoonful.
get one of
I
the.
don't know, I like
Get a
it.
wet bite.
No, I
It
taste
builds
it.
up.
No, get a wet bite. Don't get a dry bite. The dry bite doesn't have the fucking sauce.
No, I taste it.
She got one.
I can taste it. It's hot. That's good though. I've learned to like handle spice because of the bulldog noodles, because that's like a different level. But like I can like eat those straight, but no, I can't. You saw me crying. But like
did, yeah.
this,
This is pizza.
yeah, I probably wouldn't.
I like spicy things. My stomach can't handle it as well as the rest of me can though. So
See,
I
now I
like it. I
want an
just
orange.
die a little later.
Now I want an orange. You should go get an orange, bro.
Guys,
You want the
I
fire?
think that we should probably start our session again.
Oh yeah, maybe
yeah,
not go get an
probably.
orange.
Yeah.
Oh, it's after.
And because I'm feeling it's dreaded, shit, I have
Are you
5% battery on my iPad. That's
We
awesome.
forgot the forks
have
and
a
then we
charger?
forgot the mic.
I do. I have one here, but I can't stream and charge.
You can there's a USB-C port in the thing.
Wait, guys, today's a Friday.
Nah.
Yeah.
What time is it?
Shit, that's crazy.
What time does the CND close?
Nice.
Is it open?
4.
Hold the session
Is what?
for 6 minutes.
All right.
What time does what close?
C&D.
C&D.
Ghibli Shibak!
The place that sells coffee in the post.
It's the engineering coffee and donuts.
Oh.
Like the MC Coffee and Donuts. Best place on campus. I love the MC.
Really?
Not the coffee and donuts, the MC itself. I love the MC so much. Yeah, I could talk about the MC for hours. I've learned everything I've ever learned in my life in that building. Everything. Like any course we've taken, I learned all in the MC.
Place looks like a prison. Police space.
That's why you learn, because you don't worry about what time of day it is. I have some environment friends, and they always tell us like, "Oh, we can't study in the MC. I like to know what time of day it is." And they're like, "Oh, really?" Ha ha ha.
It's always the people who aren't engineering who say that.
That say shit like that.
Yeah.
But then me and my math friends, and they're like an intense math programs,
Or
bro.
math,
Like
yeah.
we'll stay in the MC till fucking 12. Not once. Oh, I'm hungry. Oh, I'm thirsty. Nothing. You just stay. You just don't. You don't think about your health there. You don't worry about these things. They're not relevant.
That's really bad, but I agree.
The only course I haven't learned in the MC is EMAG because I just didn't learn that one in general.
Yeah.
That's not true. I actually kind of understand a little bit.
Okay, concepts are always like they make sense.
And then you
It's
try to
the
do a question.
calculation.
And
Yeah,
then,
it's all the calculation shit.
Look, one of his biggest mistakes is making the homeworks not mandatory.
yeah.
I'm not saying I want more homework. We definitely cannot handle more homework.
No.
If anything, I think the faculty might have told them, don't give them homework. You don't understand, we had so many assignments there. But in spite of that, maybe making them a little bit graded would have been nice.
Yeah.
Because-
so it would motivate us to learn.
Because I haven't done a single one.
Not
Yeah,
one.
same. I looked at the first one and I couldn't even like convert.
Yeah, I
to
didn't know how to
Polar
do it,
because
and
I was,
then I
I'm just like,
stopped.
nah.
That's too
The
hard.
first one was just scary because it was just vector calculus.
Yeah.
Yeah.
No, the first one is
No,
actually the hardest one, I think.
Really? Oh,
Yeah,
that's I saw that one and gave up.
No,
The rest
And
of
that's
them
what I
are
was
really
trying to tell earlier. His biggest mistake, like even okay, I'll be real, guys. Like I attended a lot of his lectures. After the midterm, they were okay. Like I'm not telling you he started magically teaching at a university level, no, but they were passable.
They got
His-
better, yeah.
His issue is that when the term started, and
He
was-
just lost us too early.
he lost us too
Yeah.
early because he
Like
didn't
the
teach
first
vector.
lecture.
He didn't teach like the rho L, DL, the rho V, DV, that stuff. I didn't know that shit till 3 days before the midterm.
No, same. I looked
Like,
at
what the
anything
fuck is that
that's
shit? What the
different.
fuck is a charge density? What is charge?
Yeah,
Like,
I didn't know what he meant by those like the Y hat, you know those things.
yeah, those
Yeah.
are direction
Until-
vectors. Yeah.
Yeah, it's so easy.
And all the
Yes, about,
guys,
like, what direction this is.
the midterm is not that hard.
It's not.
I'm not telling you right now I'd rather do well. No, I'd still get the same, probably lower than I did.
If you have a good.
If we were on track of what we're
Yeah.
supposed to know, guys, the class average would have been like 80.
Yeah.
The questions were not
If
complicated.
we had a good teacher, probably.
Yeah.
The other thing is though is that like even though his notes and the content got a little bit better after the midterm, he still sounds so
He's so
bad.
boring.
He's so boring.
And he's
bro.
so quiet.
And no
then
quizzes, no
yeah.
assignments, so why would I give a fuck?
Exactly.
And I know the whole class is gonna fail, so I might as well just grind it all out 1 week before the
Yeah.
exam, do my best. and
Like
say,
I know
"Fuck it up."
everyone else is doing the same as me, so I feel no drive to do anything
Exactly.
different.
Yeah.
Like
Like,
I know no one knows it because I also don't know it.
I did homework 5. I handed it in, and we were taking it up in the tutorial, and I'm like, I did every
Everything
single
wrong.
one. Yeah, every single question wrong. And I'm like, why would I even try again? So I haven't touched the homework since then.
I mean, you will still get 80% of the mark just for trying.
Oh, I-
What?
For the homework?
Yeah, dude, I got marks on the midterm just for writing down answering bullshit.
Wait, no, pause. This is a big revelation. What did you seriously?
I mean, it's too late.
I mean,
now.
it's
There was one
5%
time that I handed
bonus.
in a homework.
I
that was
would
like
fully take it if I
1/3 completed, and the two single questions I did were completely wrong, but because I tried to follow through with some steps that seemed sensible, he gave me 80% of the mark for the questions I did try.
Oh, I thought it was like a Doug Harder type situation where just handing it in gets you the grade.
Yeah.
No, never mind. I wouldn't have gone
I
there.
would haven't done it.
Yeah. No.
And
I'm
you do
saying
have to write
solely-
something sensible. You
Yeah,
can't
no,
just
that's
write
not me,
questions.
though,
Yeah.
Jesse. Especially
I
without
guess,
the
like,
solution.
if you just
video.
made it like participation marks, like if you just
like
like
Chem.
no, yeah, like him, like if you just made it like that, it would give people more drive to at least write something down,
Yeah.
go to the tutorial, and then learn it.
Yes,
You know?
I agree.
Like I just feel like
No, he just
I feel like he needs a TA too. Like,
yeah.
why
I
is
was
he
gonna
doing
say like
tutorials
he's
too?
lacking guidance.
yeah,
Did you know him and John Sad don't communicate?
they don't.
People always assume like, oh, why isn't
Like he knows. Johnson knows
What's
what's
that?
doing.
Like what the fuck?
I'll give you guys another insight.
I wish he like John Fat King sat in one of our lectures with us and just stared the dude down. I feel like that would have
I
been
got
very
water
entertaining
that doesn't
lecture.
taste like piss.
The acid breaks down the capsaicin from the spice. and
That's
then-
exactly why I got this.
Oh shit, that's big
It's
brain.
the only thing I know about Orgo.
I feel like she's the only one that, like genuinely cares
I
about
timed
it,
myself
so,
using RapGuard
like yeah.
because
Yeah.
it's 6 minutes long.
Okay, sorry, Jesse.
All right.
Where was a distraction?
We can go back to
Wait, I was dying.
Fourier transforms. So, FYI, Fourier is going to be the hardest thing that we cover today.
Hardest?
So,
All right.
yeah, the most like the one that has the most steps or like the most convoluted. So we're gonna be pretty set after this, and we can just zoom through the rest of our practice problems after we're done with Fourier. So, as you remember, when we deal with functions that are even or odd, you can use only one part of the formula and then just times it by 2. But because in this case it's neither even nor odd, we have to use both cosine and sine so that they will constructively interfere on some portions and destructively interfere in other portions. So in this case, we have 2 different terms. The term has a special case where if it is 0, then it's slightly different than everywhere else. But we'll go through this and we will probably start with the easiest one to do. So we'll start with whatever the range of the function is. So the range of the function is from 0 to a. And our function is just 2a dx. So we can write this as LA squared. I like LA squared. That's like LA, but better. Similarly, we can just do 2a cos of n pi L dx. So if we recall that your cosine will turn into a sine, and sine of n pi will turn into nothing.
Could you move the? Yeah.
You can move the entire thing. You can move anything we want. Oh my god, so cool.
Also, could you give us a second to copy all the file?
For sure. In this case, we have 2 different variables. We have a and L. L is just like any sort of random variable that we chose. And it can be anything. Like, so it would be probably the easiest to just let L equals A. So I'm gonna do that.
Oh, and if it's periodic, L is the frequency, right? Half the frequency.
Mm-hmm. So I'm gonna get L equals A here.
Wait, why can we just make L equals A?
Because it's just any random. It's just any random constant that we picked.
Oh, and they both are this.
Because if you notice the question puts it on the range 0 to A, implying he doesn't actually give a fuck about the numerical actual value. It's more of just showing that you can, no matter what number he put in there, you could have just plugged in A and you get it. Because also you're modeling, so you're not trying to compute the final number. This whole chapter is just showing you how we can represent things differently, right? So most of the grade isn't like figuring out exactly where it goes from where to where. It's just like trying to fit it along the actual function.
So L is the range. So L defines the range within which your transform is valid.
Oh, but yeah. I
So
get it. Yes,
if you just set it to A, all of your function is encapsulated within A, so it's fine.
Yeah.
And it just makes it easier, so that's why you would pick it. So as we know from before, sine of n pi is similar to sine of 0. They're both just 0. So we actually don't have a intern. We do have a b intern though. We have
Do we need to know how to derive the cosine and sine stuff?
what do you mean?
So on
Which
like
part?
you know Paul's notes, you ever looked at them?
Mm,
You know he has an entire section where it says Fourier cosine series.
orthogonality. So I can go over derivation, but I don't think we're required to know.
Then it's good. Then we'll just act like we don't need to know it.
Mhm. Yeah.
Exactly.
Wait, sorry, Jesse. Is the BN the and like the different extensions, or what is it?
Coefficients.
So A and B and are just two different names that we've given them, so that we don't confuse them.
Okay, but they're different things.
So these are two different series, right? One is in terms of
Oh, okay.
sine, one is in terms of
That's a
cosine.
better answer. Yeah.
Oh, okay.
Actually, like, it's a-
And what
Oh,
is
yeah.
A naught then?
So A0 is a special case of AN. So in the cosine case, you notice how n goes down to 0 versus this one goes down to 1. So in the 0 case, it's actually slightly special. And this has to do with orthogonality. Go for it.
It's the average of the function over its period. So it's you can just think of it as y equals mx plus b. It's the b term that like shifts your function up and down.
Yeah.
Why is that? Oh, so it has nothing to do with AN.
It
No.
does.
It's the first
like
term.
cos 0, but that's 1, so it doesn't really matter. And it's
That's a
the-
good way to explain.
Your graph will look
Oh, okay,
almost
so
the
you-
same.
Okay,
You-
that's a good way.
Oh wait, A naught is cos 0?
Yeah,
Yeah.
since we're going from n equals 0 to infinity, the first cosine thing is cos 0. And then
Jesse, what
whatever
does it
else.
say where you're
And
writing
then you
right
don't
now?
need to
To the
include
left of
sine
where you
or
just wrote cosine what?
Sine
and
starts
what?
from 1.
Where you were just writing. So
Am I-
that's cosine and what?
Cosine n pi and then
Minus
cosine
cosine 0?
0.
Okay, thank you so
Yeah,
much.
my bad.
Because
my,
if you
my
do
right
sine,
No, no, it's very
that's
good.
just
Thank you
Oh,
very
right,
much.
yeah.
and
Okay.
that term doesn't matter.
And it's because they're adding together, right?
Mhm.
Well, so let's see.
It's actually quite a fun thing to learn this stuff because I've noticed it's a lot more arbitrary than a lot of the stuff we do is.
Yeah.
I don't like arbitrary
Yeah, me too in the start, but then I realized like technically he can't tell me I'm wrong.
things.
So the problem is
Valid
like
point.
once we get to a certain point, like the engineering side of math only tries to like teach us what things are, or like how things are and how to apply it, versus like we don't actually learn any of the derivation or like any of the underlying theorems. So it starts to feel jumpy after a certain time, right?
Yeah.
But it's also really necessary to jump because you can't really grasp all of mathematics and like applied math just through like understanding every single thing. That will take way too long. So I think at some point like engineering math is bound to jump.
Hey, sorry, one more stupid question. So the other one you did, it was n plus 1. Why is this one n and not n plus 1? Wait, sorry, why is the other one n plus 1? I guess I should ask.
Where
And the other example that you did, where'd it go? One second.
n plus
Like
It
the
was
final
negative
solution.
1 times
n
negative
plus
1
1.
and 10.
That's because there was this negative term
Yeah.
that I brought inside of
Oh, okay. Yeah, that makes sense.
Oh, so this is a safe environment. There are no stupid questions.
Yeah.
a. Yeah. Okay, so we can write the an term at the very beginning because the a0 term at the very beginning because the an's don't exist. And when n is 0, this is just cosine of 0 and plus the rest of the terms, which involve bn. So bn is n pi to a sine n pi x. We can write L as A as well. And then n minus n is 1. This is 1, so we erase that. Oh, we did not intend to do that.
The reason the sine function starts at n equals 1 is because n equals 0 will just make it 0, so it's always a factor.
Exactly.
Okay.
Yep. Good. Everyone's getting this. I'm happy.
I'm happy too. I will probably
You're
look
teaching
at
it very well, so.
trying to grab the
Oh,
index.
yeah.
Oh no.
Could you go back for like 2 seconds?
Yeah. Oh, actually, there's a freeze function. Oh my god, this is amazing. Okay. There's a way to freeze.
It's like
It's like someone
Is this
needs to know
math?
for this.
That's too far. We're not there yet, you know.
No, it's not. Oh,
For the record, Forrester is using Paul's notes not just as a resource. He's teaching the entire course using Paul's.
He
I
said
like-
this in class.
Explains a lot
He said
of
this in
things.
class.
No, but like it's
yeah,
like
I can't.
there's no originality.
You
As in,
should
like
get
even
paid.
the examples he gives for the applications, he takes the exact same ones Paul talks about.
Okay, the other thing is that
He doesn't actually
Paul's
know
online
he's
notes
I
are
promise
not
he
like a
doesn't.
full textbook. They're not like a comprehensive, includes all details kind of thing. They're
What
just,
is?
like Paul's online notes? They're not like a full textbook level
Yeah.
of information. So then the things he's teaching us, he's paraphrasing from something that's already paraphrased, and then not explaining to us what anything is. And it kills
You know
me.
the iron bar thing he talks about, how like if we heat one
Oh,
side and
yeah,
don't
no.
heat one side? Yeah, that's in Paul's too.
This?
But I feel like there's only
Yeah.
so many
It's not
examples.
just-
you
I
can
don't
have
care.
this
That's just a
level.
different
I
Like,
don't he needs to step up your game first.
Oh,
I think if he just taught, even if he used the same examples, if he just went, okay, so we're starting.
Fourier.
yeah,
or,
like just
"Hey,
say like we're starting
in class."
Fourier. I'm gonna go derive what a Fourier series is.
You didn't have to say, oh, this is a Fourier series. Like after we derived like whatever.
The whole
we
thing,
figured
and I'm
out
like,
was
oh.
And those,
Even Laplace transforms, he didn't actually say what Laplace transforms were. He's just like, he just started doing them, and then literally
This
I
is
had
a
to,
Laplace transform.
yeah, like I need him
Where
to
did
be
we
like,
start the Laplace
yeah, this is
transform?
a definition of a Laplace transform, and like I feel like he just needs to give more conceptual.
He really likes the way you like figure out things through like examples.
it's because he assumes we're a lot smarter than we are. That's
Yeah.
the problem. Seriously,
I think a lot of our profs do that though.
They teach as if we already know the content.
Because they know the
So,
content.
I think we are pretty okay with Fourier, like doing the problem. So we can come back to the rest of these a bit later if we feel like it. I'm just going to put this in the parking lot,
So
and we can.
can I quickly say what I understood, and then
Yeah.
you tell me where the gaps in my logic lies?
Sounds good.
So I have my function.
Yeah.
Okay. Could be anything.
Mhm.
And then first step is finding, I'd say, whether it's even or odd. That's very
Yeah.
simple. Just either look at the graph or plug in, try either or. Great. We figured out which one it is. It could be both. And then you have your appropriate functions, whether it's sine for odd or cosine for even, and both if it's neither, or if neither or it's both. Anyways, then I find L based off again the given. So now I have all my tools.
Mhm.
So then I take those functions and I start finding terms of an and bn if they exist. And then I start writing out what the series equivalent of all those terms is, how it progresses, based in terms of n. And then I just write down what the final function is. How did I model this function using sines and cosines?
Literally, that's it. You're just rewriting the entire function.
Yeah, it's actually quite sweet. I think this is gonna give us a lot of grades on the exam. Like it's free marks, guys.
Yeah, because it does have a lot of convoluted steps, but it's not actually that difficult. None of the individual steps are difficult.
I feel
Yes.
like I'm gonna mess up
So this is-
integration though.
I literally messed up one of the assignments.
But you're
'cause I
really
just added
only
2D.
integrating like cosines and sines, right? So it's not that crazy.
Yeah, I agree.
Yeah, I know, but I'll find a way.
Yeah. All right. So we can
I'm really
move
good.
on to our other transform, which we talked about, which was Laplace. So what a Laplace transform is, it's a kernel function. What a kernel function is if you have data that is not linear. Let's say you're trying to like segregate. Let's say you're trying to draw a distinction between the dots in purple versus like the dots in green. How would you draw a distinction, right? You can't draw like a straight line through the space. And arrive at any sort of distinction boundary line between the two. So what you can do is perform a transformation where you warp your space. So for instance, if I were to imagine this is like a piece of cloth, and I take my pen and I like poke it over that top, right? And now I end up with a space that's curved like this. So now I can say, okay, all my purple dots are above this, are above a certain height, and now all my green dots are below a certain height. So that's what the kernel function does. Laplace transform is one of them. it's not particularly useful for like solving like for just like as he said, he's a physics researcher and he doesn't use it, but I think it's the precursor to some of the other kernel functions that might exist that's useful for like doing things like machine learning. So I don't think it's super like what's it called? I don't think this is a pretty simple transform as well, so it's not super difficult. The thing that you need to remember is the formula for Laplace transform. So again, you have your original function, and then you have your new function. And because you worked space-time, you now need a different coordinate s to represent your where you are in the space. So to transform, you would do.
So are you sort of adding a new dimension to it and then differentiating based on that dimension?
Somewhat, yeah. You can imagine that.
You're changing domains.
Yeah, you're changing domains. Yeah. So you can also represent the Laplace transform as a Jacobian, which is also a way to warp space-time. And the Jacobian representation would allow you to do this. Would allow you to do all of this in matrix representation, which is what you would implement in a computer. If I can actually remember the definition of Laplace transform, that would be great. Let's see. So S
Is it
equal to
E negative st?
That's
F of x times E to the
yeah, I think that's correct. Yeah.
F of t.
Oh, my bad. Okay.
Sx.
Thank you.
Dx.
Ah, shit. Thank you. So unfortunately for this one, there is only like a way to go one way, and the only way you can go the other way in an easy sort of sense, instead of computing like a big differential equation, is just to save all the results when you do the forward transform, and then look up on the table when you try to do the inverse, which is why we have a table for this. And which is why this is not a very good one to be using on the computer, only because there is a way to invert a Jacobian though, which is slightly easier. So the number 2 only has a matrix representation. It doesn't have a function representation, so to say. So we can attempt to solve some problems just using the definition of Laplace transform. I think 2 of the ones that we really need to know is t to the n, and knowing how to do this for t to the e negative t. And then it's also useful for when we're trying to solve differential equations. So I would just do an example with solving a differential equation with the Laplace transform, but solving this requires that you have the initial conditions. And it's not just any boundary condition, it must be the initial condition, meaning what it is when your t is 0. So again, you can do this transformation with respect to space or time, but it's more common to do it with respect to time because time typically has an initial condition. And you typically want to evolve your state. So we can attempt one of them. Let's see. Should be fairly simple. X should be t to the n, e to the minus x. So t to the n